turn it to it.
Good morning.
Good morning. Good morning.
Are we all full of donuts, or is it just me? The problem with these donuts is, one is, I'm speaking...
Hold on, let me stop you right there. There's no problem with these donuts. Maybe the vegan ones, but no.
No, I think those are fantastic too. But my problem with these donuts is that one is not enough, and two is probably also not enough, but I still feel really terrible after that second one.
All right, don't think, just answer. Favorite donut? Who said fritter? Yes, fritters, thank you. It's not like apple fritter, if you've ever had their apple fritter. It's not quite that level, but it's so good. And that was my one donut.
Chocolate cake too, yeah. Old-fashioned.
Yeah. We good?
How many donuts did you order for those that weren't here yesterday or didn't hear?
30 dozen.
Quick math, anyone?
360. Yeah.
Oh, okay.
Yeah.
This is why I'm the MC. I'm way too dumb to do monitoring stuff anymore.
All right. Some quick notes before we kick off day 3. Everybody had a good time at sponsor parties last night? Yeah? I saw lots of photos, lots of toots, I guess it's now the thing. Yeah, no, that was awesome. Yep, donuts, loving the donuts. I guess on a personal level, I just want to thank everybody for being so nice. And I hope that doesn't sound trite or like obvious, but like it's a technical conference and we're like engineers and shit. So like I don't take any of that for granted, but no, seriously, it's been a fun week. Y'all have been awesome, super engaged, very positive, and I really do appreciate that. Yeah, so I mean, for today, I don't know if folks know this, but like I've explained it before, but in case y'all haven't been here, the way we generally do the conference kind of story arc is that we generally start high level, all of this year's evidence to the contrary. We generally start very high level, conceptual, like big thinkers type of stuff, and they get increasingly technical. Second day tends to be hands-on, practitioner type stuff, and day 3 is like really nitty-gritty, like technical, open source projects, that sort of stuff. So if it feels more hands-on, it feels more technical, generally speaking, that's why it is. Yeah, I guess, I don't know, I wanted to call out that like day 3, Wednesday, was like the day that like Grafana was like announced as a formal thing 10 years ago, like here on this stage. So that was kind of exciting. I'm really happy for Torkel and the team over at Grafana Labs. Yeah, I don't know. Pete's been egging me on to like do some kind of closing talk. There's 2 topics we've been batting around. One is like, I had this, I'm not gonna say the company, but I actually built a ganglia. Does anybody, okay, hands up if you know what ganglia is. Keep your hands up if you've used ganglia. God bless.
It's great if someone else runs the Hadoop for you, okay?
You talk about, like, what were we talking about, the single pane of glass, the wall of, a wall of graphs, like, oh yeah, pain indeed. I actually had a, we'll call it executive level influencer, ask me to, like, they needed ganglia so bad that I actually wrote a web stack from scratch that implemented Prometheus API on the back end and rendered ganglia, well, what looked like ganglia graphs in the front end. And that was both like the pinnacle and ultimate shame of my career. So there was that talk I was considering. And then also I was explaining to Pete how I build badges for this conference. And like, for those that don't know, I have an open source, like a lot of my stuff, like, I mean, I think this looks like SRE type stuff. Like you script stuff together, and you make things, and it's like small, sharp tools. And these badges are a result of a similar workflow where I use Rake and Bundle and Ruby, and I generate HTML and convert it to PDF and print it out, and I actually upload the data into Heroku Postgres, and it's shameful, but it, you're wearing my shame, so congratulations.
When he actually told me the whole step, this was a very summarized, it took him 5 minutes to explain the step-by-step process to actually print a single badge. I felt really bad for him the whole time.
Aristocrats. Okay, anyways, yeah, so if anybody's curious about either of those, we may just dive into it, or, I don't know, beers, we'll see. Oh, I just want to just remind everybody we're having a raffle at the end of the day. So if you're planning to be around the end of the day, and hopefully you are, if you haven't already turned over half of your ticket and the back of your badge to the sock booth, please do so. And we still, I think, have extra socks to give away. But if you haven't done that, do that so that you're eligible for the raffle, because that's how we pull the raffle.
What are the raffle prizes?
What is the raffle for? I've got so many good questions about what is the raffle for. Believe it or not, I'm not trying to be mysterious. Generally speaking, I don't know until the last day what we're going to be raffling away. So if you see me running all over town, that's generally why I'm doing that. In this case, I am maybe trying to be a little mysterious. There's one thing that's topical that I've been trying to track down all week. I have managed to do it, so I have to actually go pick it up today. But it's funny, I got a question yesterday, should I and I'm not calling anybody out. This is a perfectly valid question, but they're like, should I reschedule my flight? Yes, you should. No, you should not.
That is how good the prize, assuming he can actually pick it up. He's struck out.
It's not a Tesla. You're not going to be able to drive it home. But yeah, so please, if you're going to hang around, please hang around for the raffle. It's going to be fun. Just going to call out a quick schedule change. We're having our first speaker of the day, Alex Hidalgo, who was scheduled to talk. He's going to be coming on later in the afternoon. He's had some issues with his back, so we're trying to accommodate that. But otherwise, should look pretty similar, and I'm looking forward to it. It should be a lot of fun. So here, I'm going to hand it over to Pete, and hope everybody has a great day.
Awesome. Thank you, Jason. All right, this next speaker, it's kind of funny because our next speaker and I are from the same place. Not actually, originally. You'll hear his voice and realize that we're not from the same place. But we both live in Boston, but not only do we both live in Boston, we live in the same town in Boston, which is a town called Newton. And hilariously, it's like we're like 4 miles away from each other. And it was much easier to fly like 3,000 miles to like grab a coffee than just, drive across town. So I was really excited to spend 6 hours on a flight so I could hang out with our next speaker. So let's give a big round of applause for Richard.
Hey everyone, thanks for making it out early on the last day of Monitorama. I'm Richard Benwell, I'm founder and CEO of Squared Up. We provide a unified visibility layer on top of all of your observability data, no matter where it lives. And I think I've sort of met many of you up at the booth upstairs, so thanks for swinging by and talking to us at the booth. Today I'm talking about joining the dots with OpenTelemetry semantic conventions. But before I get to that, I just wanted to frame the conversation around what I see as the two sides of observability data. On one side, we have the question of how do I collect and store that data? And the problem there is how to do that at scale. And there's two types of scale. There's an amount of data scale, but there's also the scale of the systems that we are monitoring. So the number of applications, services, and the infrastructure. On the other side of the equation is how do I find and use that data for answers? And again, the problem there is doing that at scale. How do I find that data? How do I find the right data to look for? How do I correlate that with other data so I can get the big picture? And it seems to me that we spend a lot of our time on the left-hand side of this, a lot of our sort of engineering effort. And when I was here at Monitorama last year, I was sitting in the talks and sort of really feeling like there was a lot of effort and engineering smarts going into the collection side. Doing this at massive scale. So this is Suman from Slack talking about sort of their petabyte scale data collection pipeline. Pretty awesome stuff, pretty impressive stuff, especially at that scale. My favorite slide from last year was this one from Natalie Serino around the timeline of an observability project. What you think it's going to be, set up, the left-hand side of that equation, and then all the fun stuff, right? Using that data to provide value to my teams and to my business. The reality, that setup actually takes time to find how you collect that data, moving that data around, storing and maintaining that data. And then the fun stuff, the good stuff, the value to my business, actually not enough time to really focus on that. And we end up just defaulting to a lot of the practices that we've always had. Now, when it's engineering time internally, and perhaps we're spending on storage costs and so on, and we're sort of rolling our own, it's actually sometimes quite hard to see what the real cost of collecting all this data is. When we pay an external vendor, that cost can be very clear. This has sort of come up. I'm surprised this particular tweet hasn't sort of appeared yet in the slides, but obviously it came up in Joe's talk on Monday around the cost of observability, just really maybe have gone too far and not sustainable. Now, this is just sort of one data point. It's a little bit of a moment where I think we're all sort of checking how much we really are spending and how much value we're getting out of our observability data. So when it comes to these two sides, we seem to be focusing a lot on the left and perhaps not enough on the right. And there's really sort of two questions. How can I spend less? So how can I spend less effort, spend less of my time, and ultimately less of my sort of business money on the collection side, and make sure that I'm maximizing the value of using that data, making sure I get visibility of my systems and my applications, make sure I can understand my systems, make sure I can find answers. So what I'm going to be talking about today is how we can do both of those things, spend less on the collecting side and hopefully get a lot more on the using side. Now, at the moment, all roads, all observability roads lead to OpenTelemetry, the hot new project. High quality, ubiquitous, and portable telemetry to enable effective observability. That's from OpenTelemetry.io. Pretty much says it all. I think we all absolutely want that. And no wonder that's the second most active project after Kubernetes. When we typically hear about OpenTelemetry, it's normally around this issue, which, not about that issue, but about this issue, which is vendor lock-in. We have deployed perhaps a proprietary, and when I say proprietary, it doesn't necessarily need to be a paid-for third-party piece of software. This still could be an open source project or a technology that you've deployed. We're having to deploy proprietary instrumentation in our code. We deploy perhaps proprietary agents on our infrastructure. They're using a proprietary protocol to store that data back in some matching proprietary backend, the metrics, logs, and traces. And to change this is very hard indeed. And that's sort of generally what we hear about OpenTelemetry solving, is providing us portability. So replace that with OpenTelemetry instrumentation, an API and SDK on the code side. That allows us to then ship those signals out through the OpenTelemetry protocol, either to a collector where we can do some control plane stuff there and then sort of filter and enrich that data and then send it on, or we can send it directly to backends that either support that OpenTelemetry protocol, or we can have some code and some software in between, just as adapters that effectively allow us to swap in proprietary protocols at any point. So this is generally what we hear, is OpenTelemetry giving us this freedom of where we send our data when we're collecting it, and making sure that we have that freedom of choice around the observability backends. So hopefully, as we start to adopt OpenTelemetry across the industry, we will have solved the problem of getting data in, giving us a lot more flexibility and making sure it's a lot less effort to do this. But what about the problem of getting the data out? So again, that other side of the equation. Once it's in those backends, what about getting the data out? And this is why I wanted to talk about the other bit of OpenTelemetry that doesn't often get talked about. We often see that diagram, we often hear about the instrumentation and the controller and so on, but the other bit of OpenTelemetry is perhaps, certainly from my point of view, the most exciting bit, and that's OpenTelemetry semantic conventions. I've got to admit, it's a bit of a scary name, but it's a very simple and powerful concept. I sort of find anything with the word semantic in a little bit off-putting. I'm not sure where it's going to go. It always feels a little bit pedantic when they talk about semantic. But it is a very simple and powerful concept. If we take a look at our telemetry data, so sort of a simplified view of what OpenTelemetry gives us, we have our metrics or sort of time series as they're stored in our database, with metric name, instrument type, units, and data points. We have our logs, timestamp, severity, the actual log body, and our traces, or more specifically our spans, right? A name of a bit of a work, the context, which we can then flow through, parent spans, start, end, and the status. So that's our telemetry data. But what OpenTelemetry does on top of that is add attributes. Now, we're quite familiar with these in the world of metrics. These are our labels that we store with our data points. But we can do the same with logs, and actually OpenTelemetry separates this out from resources and attributes, and I'll talk about that in a second. And we can also do that with our spans. We can add in these arbitrary key value pairs. So that's pretty cool. So as well as the actual data, whether it's sort of a metric or a log entry or a bit of work that's being done in a span, we can attach attributes to that. Now the problem is what should these attributes be? They can be anything, but we don't really want them to be anything because otherwise we're going to end up in a mess of data again. And that's all semantic conventions are, is giving us a standardized set of attributes to use. So just as an example of one, probably the most essential attribute that OpenTelemetry really requires and expects you to provide is the service name. And that is going to describe the resource, effectively, where the telemetry is coming from. And this is one of the sets of resource attributes that semantic conventions provides. So a very simple example, this is taken from the GitHub repo where all of these semantic conventions are defined, and so you've got sort of nice change control, and you can see, see changes around these semantic conventions when they do happen. So here we've got the attribute name, service.name, so that should be the key, the key string. And it gives us the fact that it should be a string, gives us a description of it, gives us an example, and it says it should be required. But what's really cool about semantic conventions is it even explains what the value should be. So here it's even explaining that it should be the same for all instances of a horizontally scaled service. If it's not specified, use unknown_service with the executable name, or just unknown_service if we don't know the executable name. So really nice prescriptive information, guidance around what values we should actually be using. So that's a very simple one. Once we've got service name attached to all of our telemetry, we can now very quickly find the logs, metrics, and traces for a particular service. So we can filter across any database that's storing this data and pull out the relevant data. So very, very sort of powerful way of just making sure that at a basic level we can pull out relevant signals. The resource attributes, though, cover really pretty much anything you could imagine, used to describe sort of things or entities, again, where the signals are coming from. So functions as a service. We'll have the function name and the function version, often also then combined with the cloud resource. If that's deployed, obviously, on AWS, GCP, or Azure, we'll have the resource ID. But again, we can see here that they're standardizing the names of those key value pairs. If it's running in containers, we'll have the container name ID and the image and so on. If it's on just a host, the host ID, even, so, for example, the OS. So all of the signals that we're collecting, we're now collecting standardized metadata about those signals. And that's going to be amazingly powerful when we want to start searching for the right signals. So for example, if we use the resource ID here from some logs, we can now correlate that with perhaps some configuration data that we're pulling out of our cloud APIs. So if we're connected to AWS, we can correlate that with perhaps some AWS status. So as well as resource attributes, semantic conventions define some trace and or sort of log attributes. They can be used in either. And these describe the execution context. So if you're making an HTTP call out to a server, what's the information about that server? If you're logging something from a particular bit of code, like an error, you can include the code specifics. And I like these on the end, the other pieces here. We've got things like even like the end user ID. So if we are going to track the user ID in perhaps some logging or some spans, don't just make up whatever your key value pair is, use enduser.id. If we're actually using feature flags, so this ties in with some standardization in the open feature spec as well, we can include that in our logging. So we've got a much better understanding of what's going on, and we're able to correlate this information with other data. So for example, if our logs consistently use enduser.id, then we can more easily correlate user-specific logging with other data, like our service desk data or our customer data. And there's many other attributes that semantic conventions provide. I'm just providing a little sort of sample here, but anything to do with databases. Semantic conventions also, on top of all of that, standardizes the names of our metrics, what instrument types they are, and even the units. So the more the data is standardized with OpenTelemetry, semantic conventions, the more straightforward it's going to be to use that data, because we know what data we're actually have in our database and how to use it. So an example metric, for example, we've got the name, http.server.duration. It should be of histogram type, and it should be seconds. And then you can see that with the metric, it's also defining the attributes that should accompany that metric. In terms of metrics, there are a huge number of them. Again, all standardized, so rather than proprietary tools and different open source implementations of data collection using arbitrary metric names, we've now got a standard set of metrics across pretty much anything you could expect. If you're thinking, well, how am I going to keep track of all of these things? The good news is that a lot of this instrumentation is automatic. That's a big part of what we get from OpenTelemetry semantic conventions. We just have to say, instrument this stuff. Those implementations will use those semantic conventions. So in many cases, we don't even need to think about making sure we're collecting this in a standard way. We can just sort of consume it in a standard way. If you do set custom attributes yourself, obviously the guidance is to try and use those semantic conventions wherever you can. And those semantic conventions are just going to be building, so hopefully there should be something relevant to what you're trying to track here. I perhaps should have started with this, that the semantic conventions is currently, most of it is in an experimental status. The good news is it's moving rapidly towards a stable status, so there's a significant effort underway to reach stable. One of the big sort of pushes at the moment is that the group there are merging in the Elastic Common Schema, which defines a lot of these semantic conventions for logging. So that's sort of hopefully one less standard to have in the community and to consolidate around OpenTelemetry semantic conventions. A particular note is that those HTTP attributes that I mentioned just there, they've changed significantly. So if you are looking to start to adopt OpenTelemetry over the coming sort of months, consider your semantic convention compatibility. In particular, I think the current plan is to have new implementations use the previous experimental schema, and for you to actually have to opt into the stable schema when it's released. So if you are starting to deploy OpenTelemetry, you might want to opt in to use the forward-looking stable schema. There's a link there. I'll provide the slides after the talk if you want to just follow through to that and just sort of read that guidance around the move from experimental to stable. So that's OpenTelemetry semantic conventions in a nutshell, hopefully. And sort of coming back to the why, so what's so important about this and how's it helping us spend less and get more? Semantic conventions will give us greater portability of data, which I'll talk about in a second in more detail. It's also going to give us greater usability of that data. We're going to be able to find that data more easily. The tooling that sits on top of that data will be able to leverage those semantic conventions to give you much more guidance around what to look for and how to correlate it with other data. And that data is going to be much more connected to data outside of our observability data. Like that example of the user ID being able to map onto our customer databases more easily, or the resource ID mapping onto the information we have in our cloud providers. So I just wanted to finish with sort of few discussions around this and sort of the hopes and dreams of what OpenTelemetry semantic conventions will give us. I think, first of all, when we come back to this idea that OpenTelemetry gives us the freedom of choice, I think there's less freedom than we actually think. Although we can send that data to any observability backend, typically those observability backends are tightly coupled with the front end, right? We send it to one vendor, one full stack observability tool, or perhaps the visualization layer that comes with sort of the trace database. We're often tying into the front end by sending the data to the back end. And I think Paige talked about this a little bit around that sort of single pane of glass yesterday. Can we always send all our data to one tool? Once we start committing to one tool, we feel like we need to send all that data to one tool. And often we end up spending on putting that data into that tool just to get it out in a standardized fashion. So even, for example, if we might be sending some data to AWS CloudWatch and paying for it there, we then have to pay to get that data into our tool that we're using for visualization and analytics. So we pay for it twice by moving into that second tool. So by locking the sort of back ends into the front ends, we're actually locked into, I think, a vendor still as more than we sort of realize or do you expect from that OpenTelemetry collector architecture. So what semantic conventions will give us is that idea of standardized, connected data being stored in those databases. So we can collect it, we can send that data to any database backend we want, but we'll know that that data is in a standard format, which means that we can plug front-end tools into that data across any database. And so that's going to allow us to choose our backends more wisely. We're not going to just be sending it to the backend that's coupled with our front end. We can send our data to the backend that's going to work best for scale, cost, and performance, using David's three measures yesterday from storage. And I totally agree with David when he said around the backends will become, or the storage layer will become more commoditized. We shouldn't be having to send these tools, this data to particular tools just to get the data back out again. We should have free choice. And it may even be multiple different tools. Because this data is standardized and connected across, we can correlate logs, metrics, and traces across those three. And we can also correlate it with data outside of metrics, logs, and traces as well. So we can send to an optimized metrics database, an optimized logs database, and trace database. We could send to multiple different databases. We can leave our AWS data in CloudWatch, but we'll take our containerized logging through into Prometheus still, and have multiple different places where this data is stored. But that's okay, because the data is going to look the same wherever it is, and it's going to be connected across those data stores. So it gives us a lot more flexibility, so we can start to spend less on where we store the data and focus a little bit more on how we're using that data. And of course, then when we choose that front end, we can really focus on the use cases and the value that those front ends provide. And there's so much opportunity for the visualization, but particularly around analytics. Obviously, we haven't heard much about AI this week, probably in a good way. There's so much more to do there with the data we collect. And we don't necessarily want to be locked into one vendor because they have a cool analytics capability. We don't necessarily need to pay to store the data in that tool just because they have that cool analytics capability. Ideally, that analytics capability would sit on top of the data where we have it and wherever we want to store it. So we're heading towards that standardized connected data. I think it's going to be a fantastic thing for our community in general. And when it comes to sort of hopes and dreams, I think this is sort of the one big step that I hope we can make, which is, can we build a standardized observability query language? So the good news there is that there is a new working group under the CNCF to look at this. It was mentioned yesterday by David as well, looking at a query standardization. So they've already looked at and surveyed a lot of the query languages out there. You can see just I'm not sure if that's a complete list, but certainly that's the list that's in that charter. Now, whilst other domains like business intelligence within our businesses, they standardize around SQL, right? Doesn't really matter where the data is. They can run SQL queries against it. Within the observability space, we've ended up with a number of different query languages. And again, it's tying us in to a particular back-end and front-end. So can we get to one common standard? I'm going to be very excited to see that. And it ties in very nicely with those semantic conventions, because as well as having perhaps a standard query language, we know that we can query against particular attributes and for particular metrics, and the data is going to come back in a standardized, expected way as well. So real, true portability of our data. And then just to finish off on, I think, really the sort of true power of semantic conventions and what I hope we're going to see a lot more of is accepting the fact that although we talk a lot about metrics, logs, and traces, we cannot achieve our goals, we cannot troubleshoot those issues and deal with those unknown unknowns just by looking at our metrics, logs, and traces. It's just not enough context. There is so much more going on in our systems that is beyond what we're collecting with our observability data. So for example, our applications are running on infrastructure where we've got some configuration data somewhere. That is not stored and not considered observability data, but it's key to working out what's going on and where to look. The status of that infrastructure, if it's a third party, the cost of that infrastructure. Our developers, of course, are making changes, so code changes with pipeline deploys, and we're tracking issues. That's not considered observability data, but it's absolutely key to troubleshooting problems. And then if we look more sort of on the customer and user side, on the user we have logons, purchases, service desk tickets. This is all absolutely critical stuff to understand what's going on in our system, but it's not considered observability data. and ultimately the business, aligning what we're doing as observability practitioners with what our business needs, which is to make sure those business metrics are performing. And so what semantic conventions will allow us to do, and what I sort of touched on when talking about some of those conventions, is allow us to tie our metrics, logs, and trace data with data in that sort of broader scope of things, whether it's tying in users with user telemetry and product analytics, or the metrics associated with business metrics like cart conversions, or tying in resource IDs to the infrastructure data as well. And so ultimately what we're trying to get to, which I think a lot of us are now starting to talk about with connecting data, is using graph analytics and connecting the dots across our data to fill out that whole model of our systems. Now, I know Dylan talked about this yesterday around that sort of mental model. We really need help to understand how our systems are constructed, how they're connected, and how this data is correlated. So, for example, when we are needing to troubleshoot an issue with customers having a problem with our application and they're raising tickets, typically what we're actually trying to do is not sort of where do I look initially, is who do I get involved? Which dev team have potentially made a change that I need to track that to? And that's my challenge. I've got the customers raising tickets with a particular issue, and I'm trying to find out which dev team I need to escalate this to, because there's perhaps a change that's been made. So by correlating data using those semantic conventions, we will be able to map all the way through from that customer-facing data to our dev team data and those changes and those deploys. Even though that's not considered observability data, we need to leverage those metrics, logs, and traces to understand how those two customers and dev teams are related. So I talked about this at Observability Day at KubeCon, North America last year, so if you want to go learn more about that, I talked about why large-scale observability needs graph. At the time, I wasn't super aware of semantic conventions, because not many people were talking about it. But it is absolutely essential for us to start mapping our data together and having true portability of our data. So to summarize, OpenTelemetry semantic conventions, scary name, very simple concept, very powerful concept, which is standardizing the data we collect. So greater portability of data. We can send our data to different backends, knowing it's going to be the same data, which means that we can get it out more easily. Greater usability of data. The data we have available to us, standardized across all of those backends. We don't need to go searching for particular metric names or trying to correlate logs and metrics with other data. That's all going to be fully standardized for us. And greater connectedness of data, connecting our observability data, or what we think of as observability data, with actually that bigger picture observability data. So hopefully that's useful. You've learned a little bit about semantic conventions. Appreciate the value of it. I hope there's much more to come. So in future Monitoramas, we'll be talking about this a lot more and seeing a lot of those sort of potential wins with this becoming a reality. So thanks very much for listening. That's the end of my talk. Feel free to drop me an email, look me up on LinkedIn, or come up to the booth, and I'll be on that talk, Richard Benwell channel, and I'll drop the slides in there if you'd like to check them out later. But thanks very much.
Great. Thank you, Richard. Are there any, we've got a few minutes for questions. Are there any questions from the audience? Jack's got one.
How do you encourage your developers or engineers to use the correct semantic standards?
How do you encourage your developers or engineers to use the correct semantic standards?
That's a really good one. So I said on that slide there that we have the auto instrumentation. So where possible, that should be leveraged. Hopefully, we won't see the use of free-form strings. You can also import libraries from semantic conventions that allow you to sort of look up through all those strings. So we shouldn't have to be to get too messy with the actual sort of string values. But it is a good question about how you make sure that when someone's dumping a quick log, they actually are even bothering to add those attributes, let alone using the semantic attributes. And I think that comes back to perhaps a whole other question, which is how do we engage our developers more with our observability data in the first place, right? If it's outbound, if they're responsible for producing it, but don't have to consume it, it's going to be very hard to convince them to set the right data. If we can start showing that data back to them and showing sort of the value of that data back to them, I think they'll be incentivized a little bit more to make sure they're adding the right attributes. So that's a really good question. I think we'll have to see how that pans out, but I believe that's really fundamentally about engaging our dev teams with observability data in the first place. Otherwise, it is going to be very hard to get the right data.
Yeah, great question. Any other questions from the audience? Yeah, we got one right here.
Curious, how does the semantic conventions notion align with like the baggage API use function? Like if we have the ability to assume that, should we gravitate towards the semantic conventions?
Yes, I'll repeat the question. How does it relate to the baggage API? So the baggage is allowing you to sort of flow through metadata, right, across your spans. So again, that supports, and we should be using those attributes when we're flowing that through. So if you are wanting to pass data along through your traces, through your spans, then you should be passing it using those key value pairs as defined by the semantic conventions. Does that make sense? Is that the question? I mean, sort of the idea here is that semantic conventions are literally a standardized set of names, and values, and we should be using those wherever we're effectively using metadata.
I think there was one at the top right. Yep.
There are already well-established standards for meta exposition, such as Prometheus or input video terabyte. And so my question is whether it is a good idea to try to apply the semantic conventions to already existing standards for meta exposition instead of inventing out your own implemented format of meta exposition. Understanding applies also to laws.
So basically, does it make sense to create these semantic conventions when there's these other standards, right? Yeah.
The question is whether it's better to use already existing established standards for metric expedition, which everybody uses and everybody likes, instead of creating our own standards for metrics transfer expedition for implemented and applying this semantic convention to already existing standards. Because semantic convention idea is very good. I don't like the state of open telemetry explanation format, data custom format for metrics and follows. And I think that it's better to use just Prometheus format for metrics explanation instead of inventing your own format.
Yeah, so sort of, given existing standards and implementations that are out there in the world, right? Like Prometheus, should we be trying to sort of move towards a common standard? I think one of the things that OpenTelemetry does very well is allow quite a sort of plug-in, a plug-in model where you can adopt certain elements of OpenTelemetry. You can, for example, still continue to sort of pull that data into Prometheus in that current format, and additionally sort of send it out to another back end. And I think even with the collector allowing you to enrich and sort of filter that data, allowing you to transform that data, it does give you options. You don't have to adopt OpenTelemetry. I don't think it's sort of a forced model here. If you've got some existing implementations, then they're working for you. I think that's absolutely fine. But I think it does allow sort of incremental adoption, whether that's sort of new deployments, new instrumentation, and allowing you to use that. So yeah, I think I do think it's a great to have a standardized model. I think it's amazing work that these teams are doing. And I've got to say, this is not any of my sort of my work. There's people in the audience here on those working groups. I think it's pretty incredible the effort that they're putting in to try and standardize this, because I think it is the answer to getting a lot more value out of our data, is to try and standardize it.
That's great. Fantastic. All right, another big round of applause for Richard. All righty. Well, our next speaker is getting all plugged in. Just want to remind everyone, there's still donuts out there. There's quite a few donuts. I haven't done a recent count because if I get too close to that table, I'm gonna take another donut.
Save one for me.
So once we get through this, the speaker will be entering into a donut break, and then we'll be coming back from that for some additional speakers and sponsors. So, all right.
Yeah, let's give her a go.
All right. Yeah, perfect. All right, let's give a big round of applause for our next speaker, Timothy.
I'm really nervous, so. Okay, yes. see everything. Cool. Yeah, so what we talk about when we talk about observability frameworks, you probably want to know who I am first, right? So my name's Timothy Mahoney. I'm a senior systems engineer at IKEA Retail. I've been at IKEA for about 2 years now. I think 2 years this month. Before that, I started out as a sysadmin in the late 90s, working with like BSDOS and weird things like that. I ended up with a long career in satellite communications. I managed a satellite teleport in southern Sweden for about 16 years. Did a lot of work with Nagios and Zabbix and Cacti and trying to correlate data between the satellite system's proprietary stuff and the things I could scrape together with open source tools. Then when that job finished, I spent about 3 years working as a Splunk consultant. My colleague Robert Ewanson and I did an integration with Splunk and GCP, deploying like Splunk into GCP for IKEA. Made a presentation for the Stockholm Splunk users group using Ren and Stimpy and World of Tanks graphics called the Splunk Dirt Gun. That helped me get a job at IKEA, where I ended up in the observability pipeline team, where I work now. I'm originally from Michigan. I've been living in Sweden for about 22 years. My wife and son and our dog are here in America over the summer visiting family. Click. Not clicking. Okay. So yeah, I tried to be clever with the title. The idea came when we had this discussion where we're trying to build an observability framework for IKEA. The framework itself is probably not really interesting outside of IKEA because it's IKEA specific. It's Conway's Law, but the process and the discussions around it as we created it, I thought were very interesting. The title comes from a book by Haruki Murakami. It's called What We Talk About When We Talk About Running. The book's about running marathons. I found out after I submitted the talk and did my research that it's actually an homage to a book called What We Talk About When We Talk About Love. So this presentation could really be what we talk about when we love observability and we need to create an observability framework. So the goal that we were given in the pipeline team is to create an observability framework. We had some ADRs that our senior engineering team had come up with. We needed to provide a framework as guidance for the many engineers at IKEA that respects developer freedom, reflects our company values, and encourages adoption. So we were tasked with moving our ADRs from the draft stage to accepted and then encourage the adoption of this framework. The challenge here is that we weren't given the mandate to enforce it. So we had to convince people to use the framework. And I really questioned that whole process when we did it up until I created this presentation. And then I kind of understood why we did things that way. So we started out with the contributors, the people that really helped us get our framework in order. I'm really fortunate. I work on a team of really talented people. We have people with a bunch of different backgrounds in programming and DevOps and testing. So we have a lot of great influences and we have really good conversation. We also have people in operational intelligence where I work that run some of our tools like our application performance monitoring tools and our log analytics people. They're also very vocal, very, very conversive, and we set up the ability for us to communicate what our needs are for this framework to be successful. And I lost my notes. Yeah, so we also have engineers in the teams at IKEA that are really keen to share their knowledge and to place demands on us. So we have the outlet for that as well. They share their knowledge, their experience, and their frustrations with us. It builds a good dialogue. And beyond that, we've really had a great benefit from events like Monitorama, from people's podcasts online, like OllieCast, like people sharing experiences that we wouldn't have gained just by trying to be a self-contained team and to build a framework on our own. Then we have the detractors. We're given this great opportunity. We're going to build an observability framework. The caveat is that we have to advocate for the adoption. Being enthusiastically naive, I was sure that the time and effort that we put into this was going to be like greatly appreciated. and celebrated far and wide. It didn't take me too long to discover that not everyone is so terribly enthusiastic about what we were trying to do. You know, questions I would see turn up in our Slack channel, and the answer would be like a single dumpster fire emoji. I get that engineers are busy people. I know they don't have the time or the energy or the empathy to always answer every question that pops up. But when you have special interest channels, I think it's important to be engaging. It's part of our company culture. But it made me really frustrated and angry, especially trying to build an observability framework. You know, the effect is contagious. If an engineer who's really respected puts out a single emoji response, people follow through and just assume that whatever that case was has been dismissed. And you know, I'm really willing to accept criticism when we do things like a framework or a project, and I really don't appreciate empty criticism. So this is the enemy of our project to do an observability framework. The disclaimer here is that this isn't indicative of IKEA work culture at all. I mean, this is like single instances where people didn't respond to what I thought was an important question in a way I thought was appropriate. But this is what we were trying to avoid. You know, this goes against company culture and company values, but I really didn't want to create a framework that would be dismissed in an emoji. So we had to do the groundwork for laying up this framework for the different teams. We really wanted to reduce the cognitive overload on these teams when we present this stuff to them. Not everybody does observability in their projects. We want to present it as something great and new that they can do, but we don't want to give them the fire hose of information we can, you know, dump on them about how to do metrics, logs, and tracing, and everything that goes around it. Nobody wants to read your 50-page document on logs. Nobody wants you to sit up and talk for 2.5 hours on how to do tracing. I've done that. People said, we liked your lab on tracing, but we don't remember a word you said for 2 hours. So yeah, and we didn't want to produce documentation or technical things that we couldn't maintain. I mean, we're not a huge team of people. There's like 5 or 6 people on my team, and we don't have all the time in the world to sit and maintain the documentation. So we needed to be constructively lazy. So after the run-in with the cult of the dumpster fire emoji, my imposter syndrome was starting to tingle. You know, we had internal discussions with other teams about what we wanted to do, how we were going to build this framework, and I started to notice that people in my team, people in other teams, they're reflexively using terms, and they don't necessarily jive with the meaning of the terms. So we started to get a little panicked. You know, people are using like data model and framework interchangeably, and they don't necessarily have the same meaning. And we had our ADRs and the components of our framework, but we really didn't know how they related to each other. So we had these architectural decisions about, you know, what the data model needed to have in it, how the data was going to be transported, that we were going to go all in on OpenTelemetry, but we didn't really understand what that meant in terms of what is a framework, what is a data model, what is a standard, what are the components, and how do we relate them to each other. So that was a big eye-opener. Yeah, we're not really going to inspire confidence in the other teams if we don't know what we're talking about, especially if we're just mixing up nouns in the process. So, you know, we don't inspire confidence with that. It's really important that we weren't afraid to ask the trivial questions, though, and assume the understanding of concepts. It's really easy that, you know, yeah, I know what a framework is. Sure, I've used one, but I've never made one, and I don't know all the answers. So as we go through this process of like figuring out and doing the big Venn diagram of putting all the pieces where we think they belonged and trying to explain it to each other and to other teams what the ADRs were supposed to mean and how they related to OpenTelemetry and how they related to what IKEA needed to do, we need to look at, like, were we really understood when we were creating these documents, that we were trying to keep the documentation load down, we're trying to create something clear and concise. IKEA is a big company. Not everyone is a native English speaker. I'm the only native English speaker in our team. It doesn't mean that we don't converse in English, but it does mean that the understanding can be kind of mixed. You know, oftentimes the colleagues will ask me like, oh, I wrote this, can you read it over and make sure that what I wrote makes sense to you in English? So it's not always so easy. You know, language is hard. So as a good example of this, like when my son was born, we went to the doctor with him in Sweden. I speak fluent Swedish. I've been in Sweden a really long time. But he was like, he looked at me and he looked at my son and he said, "Oh, you're far up dagen." And I had no idea what that meant. It meant like dad up in the day. And he kept telling me this, and I'm like, I have no idea what you're saying to me. Why are you telling me this? So it's really easy that the language that we think that will be easily understood by the people consuming this framework and the documentation around it is like completely misunderstood, because from their perspective, they have understanding of English as a business language, but maybe not the context of what we're trying to convey. The other issue that we found in being understood was that sometimes people would assume that vocabulary means authority. So you would create documentation, you would get some document from somebody that they want to add in, and they would write like the most complicated English possible and super long run-on sentences, and then expect that some engineer is going to read all of that and understand it. I don't think that's a really good way to do a documentation that everyone's supposed to adhere to. Creating confusion at that level is a terrible idea. So we tried to scale back. We tried to make it as easily understandable as possible. Like try to cut down on the expensive words and make it good. You know, and we really started to think like we really need to use modal verbs for things. When we tell people that this is a framework that you need to do to adhere to that framework, even if we don't have the mandate to force you to, you know, we have to use words like should not, must, and may, and we have to be really clear about what that means logically to them when they're going through that framework. And you know, again, the dumpster fire emoji people are just waiting to read that and trash it. So we had to be really careful in the language we chose. Then we really had to talk about like how do we collaborate and where do we collaborate. This kind of seems obvious after the fact, but like we have tools for creating documentations like Confluence, static documentation, stuff about teams, stuff like that, and then you have the documentation that you've checked into Git. And we had to be really clear about like where do we publish the stuff and what is it important. If it's something like the framework, it has to be something that people can create issues for or do pull requests on. We want that collaboration, but lots of teams are looking for this documentation in Confluence because there's not necessarily a clear path for them to find it. So we really had to make sure that we had that sync between Git and Confluence for that data, and we had to make sure that people understood that, yeah, if you take issue with this framework, if there's something about it you don't understand, where do you reach out? How do you create a pull request? How do you create an issue? And then also have that available so when people do have ideas, that they know where to do it, or they know how to look and see if that's already been suggested. The other thing we had to be really careful with was semantic versioning on the framework, because we want people to consume it. We know they're going to consume parts of it programmatically. We want to make sure that they know that there's been a change to it and why and what level of change that is. And we really have to keep managers from getting involved and labeling everything 2.0 and doing all sorts of buzzword bingo and thinking that that's going to create better understanding. And it's not clicking. So yeah, so the framework itself seems pretty obvious. You know, it's a structure you're building software on. Our goal here, we needed to pave a path for engineers to ensure observability data generated in their system can be transmitted and consumed anywhere. The role of the framework is to provide straightforward means to accomplish this and ensure the data produced by the systems is consistent and correlatable. I mean, that's pretty standard stuff. What really helped here was OpenTelemetry. I know we all like throw this around all the time and we have the collector and we do all this great stuff. I think we're kind of missing the point that the underlying work on the collector, the protocol, the data models and stuff is fantastic. I mean, I don't even know how to tell you my appreciation for how well done that is. When we were looking at creating our framework, we have these data models and things. We're trying to be constructively lazy. We don't want to create everything from scratch. And here we have this super well documented, fantastic, losing the word here, specification and data model to fall back on. So we can build upon that. I can't imagine trying to do an observability framework and not having OpenTelemetry as a core component of that. So any of you that are, you know, maintainers or contributors to that in OpenTelemetry, like seriously, thank you very much. So now we have OpenTelemetry, we have a data model, we have all this stuff. The big question for us is like, what's the minimum viable set of attributes for an atomic unit of observability? This is IKEA-specific things, right? We need to motivate teams to include the attributes to their telemetry to provide that value to the business. The attributes ensure that the data ownership as well as allow the observability data to be consumed between teams. We're trying to like de-silo teams and make them understand that like, yeah, you're solving your technical issue, but there's value to the rest of the organization for this stuff. Like, you know, it's easy to lose perspective, you know, instrumenting for an application and forgetting that we sell furniture. So it's really important that we build these core attributes, and we do it in a way that doesn't create a lot of extra cardinality, for example. And in the system, we don't want it to be a super costly thing to do. I think I heard some story once about Google adding attributes to Gmail that cost like a small fortune. And obviously that's not something we want to do, but we want to make sure that for the organization level, we understand what that data is. We have the idea who owns it. The other challenge isn't necessarily adding the attributes to the open telemetry data, because that's very straightforward, it's well documented. It's how the tooling will accept that data. I mean, you could say like, I'm going to add an environment variable, I'm going to call something an environment, and then you'll find out in the tooling they've already used that. So we had a lot of work to do in communicating with our teams, making sure they understood that the attributes that we wanted to deploy that were specific to our business, like didn't crash with the attributes that the tooling was already using. We even ran into, like, we built half of the framework and we got confused about which one we were using. Were we using camel case or snake case? So the data model, you know, yeah, so what was I going to say about this? Yeah, so we had, our data model is basically an extension. What we ended up with was this extending what was already provided by OpenTelemetry to have these. So our instructions were definitely like, you know, we're creating attributes. We want it to be that it should be possible to use unambiguously the data within our organization. It should be possible to correlate between dependent services. With the attributes we added, the data must allow ownership of the data to be determined. I mean, that's a really big problem. You have a system like Splunk, you have a system like Grafana, people are ingesting data into your system. You want to know who owns it, and you can't always trust like that they ingested it with a token, and that token means that's the team that did it. I mean, some teams trade tokens around like Pokemon cards. You also want that the data should be easy to use with machine learning and automation. So like outside of the context of them just doing performance monitoring or troubleshooting a problem, some of that data is going to provide value later on, and it needs to be created in a consistent manner. So standards was an issue, so that we were tasked with giving out what the standards were, and CNCF is not a standards organization. They're not defining the size of the weight of a kilogram. But what we ended up doing was we said that our observability standard is an extension of the common industry specifications. Those specifications happen to come mostly from OpenTelemetry. We want that they should use OpenTelemetry, but we weren't mandating that everything use OpenTelemetry. That it's a little unrealistic. But we wanted to make sure that things that can and do use OpenTelemetry, they emit things with OTLP, that people aren't trying to use the collector or fooled into thinking that collector is like a Babel fish that's just going to translate all the different telemetry protocols back and forth. And we also wanted to say that, like, okay, if you have a product that can't emit OpenTelemetry, then you have to make sure that you at least get the data model in on an ingest, so we can determine business use case for it, who owns this data, where did it come from. Yeah, so components were the last part of it, right? So you have the OpenTelemetry specific components. You have the collector. You have all the pieces that you can get directly from them. Instrumentation libraries, the collector, the contrib, the Helm charts, the operator. And then the only part that we had to do to limit the amount of technical debt that we carried is we do collector configurations specifically for IKEA that have the attributes in them or can have the attributes. We have processor stuff and integration with other tools like Backstage. So that leads into examples. So we have, you have to give these teams technical examples for them to be able to follow. A lot of times that's what we get for our requests now, that we want people to adopt our framework, and the first thing there is like, how do I do this with what I have now? So I want examples that I can copy paste in. So we create our own examples. They should get a best practice example with our framework attributes already in place. So it's really important for us, like, documentation load-wise that we can point to articles on Medium or examples in repos on what we think is like best practice for what they want to do or what we expect them to do, but at the same time we provide examples that show how we've implemented our framework correctly. We obviously want like the least amount of effort or cognitive load on the teams. So the fun part, this is the part of my job that I really enjoy, is demos and labs. So IKEA has this program called Native Clouders that they started about a year and a half ago, where we take engineers out of teams, and at the time when I did it, it was 6 weeks or more. Is an intensive training in GCP, and it was a really cool eye-opener that you work with all these different engineers from all these different teams. Definitely like imposter syndrome problem the first week or two until everyone realized that everyone has some small part to play and there's no one person who had all the answers. But we as a team, in the pipeline team, we created demos and labs. As part of that Native Clouders program, we had a lab on tracing. Now we've done some other labs on SLOs and stuff, and it's a really good way to advocate for the framework, is advocate that people should do good observability and help our engineers. Like we really have to convince teams like why should they spend the time and effort implementing the framework when they don't see the value inherently in it. So we try to teach them not to be bashful with their observability data, and we want to expose teams to the framework as soon as possible and build it into their way of working. And I think the labs are a great way to do that, because the engineers that come back from programs like the Native Clouders, they've already seen how to instrument code, and they've already seen the framework in action, and they understand what it's for. I think it's an excellent means of exchanging ideas and challenges as well. Since we were involved in that program, we could see what the other labs were doing. We could see where people were doing like test-driven design. How are they doing that? How could we contribute with observability? And mostly we just want to show them that we're reasonable people. Yeah, so that is it. I think the big takeaways, if you're going to do an observability framework, make the framework something teams want to adopt. That was the part I didn't understand when we were given this task and told it wasn't like a mandated thing that everyone had to do it. We're going to create this framework and you must do it. And it turned out that we had to advocate for it. And now we have like teams and managers saying that they're going to do observability and that the framework is the right way to do it. They willingly, they're willingly taking on the task of doing it and allocating the time to implement it properly instead of us like just forcing it upon them. You definitely want to ensure that your consumers are invested in collaboration. I think that's really tricky when you come in a company and you come with a new idea. Like, how do you get people to contribute back to you? And don't present your case in a way that can be easily dismissed in an emoji. I think it's really important. And yeah, be constructively lazy. And that's all I have.
Apparently, I learned that the thumbs up emoji is passive aggressive for the Zoomers, and so now I just keep aggressively doing it to my own kids. But I don't think they've realized that like the salute one too, which I feel like kind of came out of Twitter, is also pretty passive aggressive. Like,
oh man.
So I also.
I think the dumpster fire emoji is directly aggressive.
All right. Any questions? Any questions from the audience?
We're keeping them in coffee donuts.
Yeah. Okay. We're gonna go with outside in.
Hi. Did you have access to any? Did you study or have access to any mentorship on like formal product management methodologies for selling your framework internally, or did you kind of have to just figure that out on your own?
So we totally just winged it.
Yeah. So the question was, did you have like access to any product management methodologies or anything to sell this? Yeah.
No, not at all.
Yeah. So basically, just like product management. So.
Yeah.
Yeah, right here.
Multi-partner. How did you track adoption? How did you track sentiment? And what was your team evaluated on for success?
So how did you track? Whoa, man, there was a lot there.
How did you track sentiment and adoption?
Sentiment and adoption. How did you track sentiment and adoption? And then what were you like? What was the team kind of graded on for measures of success?
Oh, okay, so it's still ongoing, so I don't know what the metrics are for that. That's my manager's question. but it is tricky to try and do it. We have an attribute that says the framework in it, so the data that gets emitted by applications that have been instrumented with the framework will show the framework version that they're adhering to. So that's one way in the data that we can see. So in our tools, we see that come up. And we also kind of like, cruise through their GitHub repos and see what's going on and see people are deviating from it as well. See people, make sure that they're doing good observability and that they don't reinvent the wheel just because they didn't know that we existed or that they weren't aware that we could help them.
Yeah, I actually really like the idea of like trolling through
Yeah.
their code itself. So in the back there.
Actually, following on from that, if you find people veering, do you try to engage with them to see if it's like a pattern that you could adopt into the framework, or is it usually like a, hey, did you know, and redirect them toward what you want?
Yeah, so how did you basically like veer people into it if they were maybe resisting the frameworks?
It's perfectly within their right to not adhere at the moment. It's a higher level management that tells people that they have to adhere to it. But I think we try to approach it as like a dialogue. I understand that some people have strong opinions, and sometimes it can give value. I don't try to just point them at our repo and say that you have to do this or anything like that. I definitely want to build a dialogue with teams. I think they like being heard, even if what they're doing might not be same.
Fantastic. Any other questions? Yeah, down here.
What were some of the common objections to adopting this framework?
Yeah, what were some of the common objections?
Oh yeah, definitely the time. I think there's the weird. I was a systems person, so the programmers were a new thing to me, and I definitely noticed that it's like they're not necessarily interested in putting the cognitive load and effort into doing something like that if they don't see an immediate value to them personally. And sometimes they're so busy with their project they don't it's either a balance of they don't necessarily see that they have enough time or they'll get enough value out of it to do it, or they don't know how to do the implementation over, so the framework on top of OpenSumTree is a big step for them. Those are probably the two biggest pushbacks.
Nice. All right, last call. Just remember, we do have the speaker channels. If you have any additional questions, also lucky for you, we're going to be starting a break, so you can just find Timothy in the central area. Before you go, it looks like, so real quick, one big round of applause for Timothy.
Real quick coffee PSA. So we still have pour over, but we're starting to run low on inventory. So if you want your coffee pour over, I would say grab it on this break. We're going to shut down the coffee bar whenever we run out of coffee, we run out of filters, or by lunch, whichever comes first.
All right, we'll see you all back at 11 o'clock. Enjoy your break. right, welcome back, everyone. I just want to say, I was walking by those donuts like a siren call. I got closer, and I was about to grab a donut. Opened a box, empty. Opened another box, empty. I am thoroughly impressed with all of you. Right. Give yourselves a round of applause. There was a lot of donuts. Collectively, about 4 million calories of donuts that we just ate. So I fully understand if you're solidly in a sugar coma right now, because it was amazing. And thank you for eating them so that I didn't have to. All right, let's kick this off. We've got, before lunch, we've got a couple more speakers and some sponsor talks. So these are all really great sponsors. Again, they're going to be upstairs, and they'll be finishing up a little bit after lunch. So definitely get up there, grab some swag, learn about their products and all their fun stuff. Last thing, if you have an iWatch, well, if you used to have an iWatch and you notice you no longer have an iWatch on your wrist, it's because we found it. Brad has it. If you can, I don't know, unlock it and identify it in some specific way, he'll help you out. So, it's beeping now. All right. Anyway, Brad's your guy. He'll take care of you here. All right. Well, with that being said, let's kick this off. Let's give a big round of applause for our next speaker, Sam.
Can you hear me okay? Okay, cool. Good thumbs up. Not checking my text. I got an extra timer there for redundancy. Okay, raise your hand if you've ever edited an Nginx config file. Okay, raise your other hand if you forgot the semicolon. Okay, and then put your head in your hands. And then you just shake it like this. And this talk is about me doing that like 500 times a day for like several months. I want to start by introducing you to me, the repeated head holder. My name is Sam. I contribute to OpenTelemetry Ruby. I'm on GitHub at PlantFanSam. I really like to shoot the breeze. So if you want to come and talk to me about anything, please do. I work at Shopify and I do tracing stuff there. If you don't know, Shopify is the world's commerce platform. We scale you from Hello World to IPO. I have a family member that makes her full-time living on her Shopify store, and I'm really proud to work there. So in addition to liking Shopify, I also like diagrams. Here is a diagram of the before state that the talk will address. So on the bottom, we have the different blocks that comprise like everything that happens during a web request. You got the CDN, then the proxies, then application code, service-to-service calls, etc. Prior to this work, logging had this more extended view of the request than tracing, and as we learned from day one of the conference, traces are the best signal. So what we're going to talk about is this red, I guess it doesn't look that, does it look red, this talk box, medium red? Anyway, we're going to talk about that little box. Incidentally, this is that red box, that off-white box is what specialization looks like in post-industrial capitalism. That's my job right there. The red box has 3 parts to it. I want to start by showing the end state, by showing like what does tracing a proxy really look like. And then I will discuss the strategy that we took, the choices we made, and then I want to talk about how we productionize this and do a little bit of demo, try to do a little demo. Could get a little hairy with the multiple screens here, but we'll see how that goes. So without further ado, I would venture to guess that most Monitorama attendees have seen a trace before, but here's one that I helped make. You can see there's 3 spans. It's a little pixelated. It's okay. There's 3 spans. The first one is a global proxy, the second is a local proxy, and the third one is an application span. And you may be thinking, okay, well, big whoop. Why do I care? The reason that we care is sometimes the traces might look like this. You can see the first span starts at 0, whatever, and then there's, you know, maybe 100 milliseconds of network latency, and we want to figure out, hey, like, why is that actually happening? What's going on here? What's going on here is that the first server is in, I believe, Mumbai, and the second one is in Council Bluffs, Iowa. So it's going across the planet, and then it's transiting the planet again, going under the ocean, and that's why it is slow. So we made some strategic choices in order to get to this point where we had this kind of visibility so we could do sort of spot checking and quantitative analysis. We had two main questions to address. The first one was, did we want to use OpenTelemetry or something else? This isn't just like a straw man for a group of people that clearly likes OpenTelemetry a lot. We had a previous proof of concept that was getting us traces out of Nginx by using a Zipkin package, and you can just kind of rig up your collector to have the Zipkin receiver, and you can go on your merry way. So that was working-ish, I would say like 55% working. But on the other hand, Shopify loves OpenTelemetry. I also love OpenTelemetry. We use OpenTelemetry to say the same thing for the 4th or 5th time in a row. We use it for tracing, and we have a lot of folks that contribute to OpenTelemetry Ruby and OpenTelemetry Ruby instrumentation on the staff at Shopify. Also, hi to all the OTel Ruby maintainers. If you're watching, Ariel, Rob, Matt, Eric, if you're there, hi. The other important thing about Shopify loving OpenTelemetry is that we're sort of fluent in the OpenTelemetry domain model, which I agree with earlier speaker who said that the domain model is a really important part of the whole pitch. And we knew that we do have a custom trace propagation format, so we were going to have to kind of crack this thing open and muck about anyway. So we thought, hey, why not do OpenTelemetry? So knowing that we wanted to do OTel, the other major question was, do we want to use OpenTelemetry C++, or do we want to use OpenResty directives? If you are not familiar with OpenResty, I think it's the next slide, so bear with me. OpenTelemetry C++ has a contrib repo that has an Nginx module that will let you trace Nginx. However, it did not play super nicely with the way that we compile Nginx at Shopify, and that was a discovery that was made by someone that left the company, so I thought, well, better just not touch that. I don't want to fight with a build problem in a language that I don't know. So I thought, well, we have OpenResty kind of working with Zipkin. Let's try to use OpenTelemetry, and we'll have a lovely working system. The other thing is that Shopify currently does a lot in OpenResty. The proxies are doing some really, really interesting stuff. So having Lua instrumentation, the ability to instrument Lua in general in a format that we know and love, OpenTelemetry, would be really valuable. And moreover, there was already a library for OpenTelemetry Lua, not officially part of the OpenTelemetry GitHub org, but it exists. And there was an implementation of tracing in API 6, which kind of looks a little bit like OpenResty. So what is OpenResty? Well, this is an Nginx config file. And you can see here that OpenResty will allow you to embed arbitrary Lua anywhere you want. You can do math, you can set variables, whatever you want to do. And each of these blocks is known as a directive, unless I'm butchering the terminology, which is totally possible. But basically, the init worker block will run when the Nginx worker boots. The rewrite worker block will run when OpenResty receives the request, but before it sends it off to the upstream that's going to actually generate the HTTP response. And then the log by Lua block will run sometime in the future after the response has been returned to the user. So this is, kind of where you're going to need to shove your Lua if you want to trace Nginx using Lua. And we use Ingress Nginx as a way of deploying OpenResty. If you're not familiar with Ingress Nginx, basically the premise is that you have a config map in Kubernetes, and when you change stuff in the config map, it updates the Nginx config file in your Nginx containers and sends, I forget what signal you send the Nginx process to restart it, but it does that for you, keeps them all in sync. It's really nice. And fortunately, Ingress Nginx also has a plugin system for OpenResty. This is kind of the shell of a plugin in Ingress Nginx. You need to have a Lua table that is encapsulated as a module, and you basically get to fill in the guts of all these methods with whatever you want to do. And then during that init worker phase, it'll call the init worker method. During the rewrite phase, it'll call the rewrite method, and so on. So that led us to this fairly naive implementation of tracing in OpenResty. I'm just going to talk through the code here So on the first line, what we're basically doing is instantiating a Shopify custom propagator because we have our own tracing format as previously discussed. And then in the second line, we're instantiating a new OpenTelemetry context object, which is a little bit of inside baseball for the OpenTelemetry SDK, but effectively that's just where you shove the trace ID and the span ID, among other things. And then we're gonna pretend like the m.tracer method is implemented, but you just grab a tracer, which is what generates spans. And then on the next line, we're reading in the inbound nginx.rec. So that's got the HTTP headers on it, so you can extract the trace ID and span ID, and that will return an inbound context, which will either point to the trace ID that was present on the inbound request, or it'll create a new trace ID, and it won't have a parent span ID, so it'll be the root of the trace. And then the next line, we start a span, and we pass in that inbound context, and we're going to call nginx.request. And then on the subsequent line, if you're still with me, it's 2 above the end in the rewrite method. We inject the new trace ID and or span ID into the HTTP headers that we then forward on to the application that's going to generate the response. And then there's this special variable in OpenResty, ngx.ctx, which is local to each web request. So if there's an Nginx worker that has it's dealing with 10 concurrent web requests. Each of those will have its own isolated table available at ngx.ctx. So we store the span on there. And then during the header filter phase, which is basically after the, I guess the application's over here and the client is over here, and I'm OpenResty. So when the application server returns a response to OpenResty, OpenResty has a chance to do various things before it returns it to the client. And what we do in that phase here is we finish the span. And that's pretty much how you naively get some spans out of Nginx when you're using OpenResty. That took a really long time to get working, but it ultimately did. We had it running in staging. And I want to talk a little bit about productionizing. So this is, there's a reason I took a drink there, because for context on productionizing stuff at Shopify, this is the horrifying reality of my life. Shopify served almost 76 million requests per minute on Black Friday, Cyber Monday peak in 2022. There's like a link to a tweet at the bottom where the engineering department, said that. And I'm sort of just trying to make changes to this extremely performant system, which is just a little bit scary. And when I'm worried about scary things in production, instead of generally worrying, I try to start worrying about specific things and make a list of stuff that I'm worried about. So this is basically what I was worried about. The first was, how are we going to get the spans out of OpenResty in a performant way? And doing so will allow us to not DDoS ourselves. If we were going to basically send a request to the collector on every request, that would be basically DDoSing ourselves. So fortunately, OpenTelemetry SDKs use a construct known as a batch span processor, so we wanted to use that. If you're not familiar, when you finish a span, there's this little, that span goes into a batch span processor, which has a buffer somewhere in memory, and there's slots for spans to go into, and as it fills up, it will eventually reach a threshold, at which point it will export the spans. You can export spans however you want, but a network call is usually conventional, and then the buffer empties out. So we knew that we needed to use this construct of a batch span processor. However, if you think back to the example of what does OpenResty look like in an Nginx config file, it's kind of just a pile of Lua. So how are we going to make sure that this all works properly? In order to do that, you have to start freaking out about the process model of Nginx and OpenResty. There's like a ticket representing this work that I did, I guess, 7 or 8 months ago. And it's just like me trying to figure out are we going to run into all kinds of problems with different threads writing to different stuff? So eventually, I figured out what the Nginx and OpenResty process models were. There's a really great blog post on the Nginx website that goes into like a light explanation of how the Nginx program models its different worker processes. But basically there's a master process that does all kinds of privileged stuff like binding to ports, etc. And then it spawns child processes. You can just ignore the ones on the left, which are related to caching, but it generates, it has these child worker processes which handle HTTP. They have like HTTP state machines that manage different requests. And each of these workers, says the blog post, runs, wow, can't read that. They run single-threaded, and there's a link at the bottom. So that's Nginx. OpenResty is an Nginx module that interacts with the Nginx event loop in ways that I do not understand. So for that reason, OpenResty, I sort of saw the OpenResty README in like quasi-religious terms. I could quote chapter and verse like what the OpenResty README said about different like promises about the runtime. So I'll commit the cardinal sin of reading text on a slide during a presentation to globally share data among all the requests handled by the same Nginx worker process. You're going to encapsulate the shared data into a Lua module, use the Lua require built-in to import the module, and then manipulate the shared data in Lua. Those Nginx worker processes, those are those square W's. I think of them as square W's now. So some more reading from a slide. It is usually recommended to share read-only data this way. You can also share changeable data among all the concurrent requests of each worker process as long as there is no non-blocking I/O operations in the middle of your calculations. Fingers crossed. For this reason, always be careful when you want to share changeable data on the worker level. So this had me shaking in my boots. We have a lot of traffic, an ideal situation for race conditions. But that led us, so we had this like, overall, the situation is, Nginx has a master process with n child worker processes. They scale with CPU cores generally. The child worker processes all run single-threaded because the blog post said so. Each request in an Nginx worker process shares the same Lua interpreter. That was not on a slide before, but it is true according to the holy text. And you can share changeable data across concurrent requests that are fielded by the same Nginx worker, as long as you don't mess it up. So that left us with the following strategy. So on booting each Nginx worker, we instantiate a batch spam processor and store it on a Lua module instance. All of the requests fielded by a given worker will push to the same batch spam processor, and that batch spam processor will manage its own export pipeline, and we're going to try not to mess it up. So on the topic of not messing up, I'm going to try to do a demo real quick. We'll see if I can manage this screen situation. Okay. All right, so a little bit of lag using the cursor here, so forgive me. So what we have here is basically a code space in GitHub. I think code spaces are cool. So we have an OpenResty config, and what I'd like to show is that there are two worker processes, each maintaining their own export pipelines. So we configure this to have two worker processes, and when we initialize the worker, we're going to run BSP, we're going to require the Lua module, and we're going to run the init worker method, and then when someone hits the demo, endpoint, we're going to run the BSP demo rewrite method, and then the BSP demo log method. And the contents of that file, really exciting sentence to say. During the init worker phase, we instantiate a batch spam processor, and we're going to set the max queue size equal to the process ID of the Nginx worker. And then we create a tracer provider, which the batch spam processor is the only positional argument that you provide to that. And then we're just going to log out the worker PID and the max queue size. And then during the rewrite phase, we start a span. We're not going to deal with context propagation. We're going to log out the worker process ID and also the span ID. and then we're going to tack that return span context onto the ngx.ctx table, and then during the log phase, we're going to wrap things up and finish. So I wrote myself some instructions. So we'll see if they work. If they don't work, at least it's not production, right? Let's see, how am I doing? Oh, I'm missing an R. Let's see, do I have Vim mode enabled here? No, okay. We're just gonna have to wait for this cursor. So how's it going? Okay, big bucks, no whammies. Okay, look at all that green. So we're gonna start another window. I'm gonna hunch over, and we're gonna just curl this 6 times. And maybe it's in the shell history, let's see. Nope, all right. I'm sure people that are better at text editors than me are infuriated by the way that I am selecting text, but I assure you it is because I am looking at a screen with a significant delay. Okay, so what do we got? 4i, okay, that should do it. Nope, backtick. All right, one more. Okay, so in our demo logs thing, you can see when we boot the worker with PID 8, or with PID 7, the max queue size is 7, and when we boot the worker with PID 8, the max queue size is 8. So we have 2 of these going. And what I want to show, one of the unfortunate aspects of this project is that viewing Nginx logs, error logs are not, you can't really customize them very easily, so this was kind of my reality. And you know what, we're not seeing any stuff fielded by worker 8, so I'm just gonna curl a little bit more. Okay, so here you see worker ID with PID 7 is fielding the span ID 5F99. And down here you can see worker with PID 7 has that span in its export, and worker with process ID 8 has the span ID 2359, and you can see that is in the list of spans that it exported. And that is my extremely exciting demo. I'll go back to my presentation now. I feel great that it didn't go, well, that it sort of worked. Let's see, maybe we should look up a word to describe how I'm feeling. All right, so back to the slides. Should be at 18 minutes here. What do we say? Well, I'll just keep going. You can take the hook out whenever you want. All right, so resiliency and performance, demo complete. Don't break the site, as they used to say at a company I worked at. So if the span buffer is full, those 8 square boxes, and we are we're finishing more spans, and there's nowhere for them to go, we have to make sure to throw them away to prevent unbounded memory growth in our OpenResty instances. So that was just a matter of verifying that the library behaved that way, which it does, very cool. It's actually an option that you can toggle, and I don't know why you would turn it off. One interesting part of OpenResty that will blow your mind is that you can do background jobs in Nginx by using the timer at API. And so the batch span processor in OpenTelemetry Lua is using timer at when it queues that. So you know, if you finish a span in the middle of the header filter phase, you don't go ahead and try to make an HTTP call to the collector before you return the response to the user. We added a circuit breaker and backoffs for calls to the collector from the OpenTelemetry Lua SDK. What we saw was that if the collector was having some issues, then OpenTelemetry Lua would just try to repeatedly protobuf encode the payload, and just again and again basically DDoS ourselves and also spike CPU in OpenResty, which is bad because if you recall, workers are CPU bound. We ended up speeding up trace and span ID generation by 92x by tweaking the way that we generated random numbers in OpenTelemetry Lua, which is the single greatest improvement that I have ever made to performance. on a multiplicative basis, I would say like in total like 0.001 milliseconds saved, but 92x, not bad. The other thing that we did was move pretty much everything to the log phase. In OpenResty, if you remember, the log phase is after the response has been returned to the user. So often in OpenTelemetry SDKs, the guidance is to provide as many attributes as possible when you're creating a span. But because the log phase is happening after the thing has been returned, after the request has been returned to the user, it really doesn't matter how long it takes. So we just ended up, you start the span, you got to generate the random number, whatever, but attaching attributes, doing regexes, all that kind of stuff, we moved that all to the log phase to save some time. And we also managed trace volume using a technique called deferred sampling. I'm going to try to go over this real quick. I'd like to write a blog post or give a talk about deferred sampling, but it's in the editor's draft of the W3C trace context specification. And basically the idea is a request goes into the proxy, and the proxy generates a span. And if it doesn't have an inbound context, a trace context, then it generates a new trace ID and sends that on to the application. And then the application makes its own sampling decision and sends information about its sampling decision back to the proxy or some other app, right? Doesn't really matter. Sends that back to the proxy, and then the proxy examines the trace response header to decide whether to throw away the span or keep the span. This is important because in a lot of SDKs, the default sampling behavior is, hey, like if the previous link in the chain sampled in, then I'm going to sample in too. And if we had done that at Shopify, we would have overwhelmed our tracing infrastructure. We aspire to 0%, we aspire to not sample and keep everything, but we're not there yet. Okay, so here's some stuff that I skipped. LuaJIT doesn't love, OpenResty runs on LuaJIT, which is a just-in-time compiler for Lua. It doesn't really like big numbers, such as trace IDs, so that can get a little hairy. There was some fun that ensued when I had to convert config map entries in Ingress and Nginx to Lua tables in the Nginx config. Oh, all right, I'm getting the hook. And very embarrassing to say to this audience, but I totally messed up the histograms, and I thought that the plugin was running extremely slowly. Then someone that I work with who knows math was like, Sam, your histograms are messed up, don't worry. So thanks, Reese. And thank you. Thanks to the venue staff. Thank you to the conference staff. Thanks to the attendees, the other speakers for sharing your knowledge. And whatever company bought me tacos yesterday, super appreciate it. And yeah, that's it. I'm friendly. Come and talk. And if you have questions, I think there's time.
There's definitely time for some questions. And we've got one right here on the edge.
No, just it's not. We're not using it because it's variety of reasons such as build issues, but it's definitely in the OpenTelemetry. Yeah.
I misunderstood. I was wondering if you had done any benchmarking.
No.
Benchmarking on the C++.
Yeah, we haven't compared. I think this is adding 0.2 milliseconds to like 0.2, 0.4 milliseconds to P95 or P99, which as we know, percentiles don't matter, but, or I don't understand them properly as evinced by the previous comment.
You're actually supposed to average them together.
Right, okay, yeah, so. Yeah.
Great.
Thanks.
Yeah, right here in the middle. Sorry, not middle, but upper middle. Yeah. When you messed up the global context, how did you find that in testing?
Oh boy, I don't even remember. Wait, the messed up the global context.
Well, you definitely would have had multiple requests.
Oh, yes, yeah. I didn't find it in. It was just in case you can't tell, like huge amount of anxiety flowing through me at all times. So I was freaked out about this from the get-go. So there's like a GitHub issue where I believe the first line is like, in Seinfeldian terms, what's the deal with OpenResty and sharing memory? So I spent about a week eventually arriving at the demo. The demo that I did is based on a ticket that I made in like August of 2022 where I'm like, oh my God, is this gonna work? But it did, so yeah.
All right, I think we're ready to mail now.
Do you have a sense of, like, with the additional information that you're packing your spans, like how many get dropped when traffic gets really high?
How many spans have been dropped? Due to the
Yeah,
additional data?
that's a really good question. Too many. I would say they're on a day-to-day basis, not a lot. Like I don't want to make stuff up, but like definitely single-digit percentages. But then during load tests and stuff, you can see that we're dropping more spans, and it is something we've got our best people working on the situation. You know.
Top people.
Yeah, but come talk to me afterwards. I'll look at the graphs and get you some answers.
Awesome. And any other questions? All right. Yeah, just remember, if you do have any more, think of anything else, drop it in the speaker channels. Individual speaker channels are available for all the speakers. So, awesome. Another big round of applause. Alrighty, so we've got some more fantastic sponsors here ready to share wonderful messages about their products and their services and how you can spend your money. And what's that?
Oh, no.
Yeah, no.
I thought it would be as loud as...
Oh no, we've prepared. Natalie is on it. Mostly because it'll kill her ears when she does. All right. So our first sponsor in this block is Grafana, and real quickly before you applaud, I think you're starting off with a special message, right? So there's a very special message that we're starting off at the very beginning. So big round of applause for Grafana.
I also take a photo of the audience while it is playing. Also, I tried to keep this short because I'm really keen on sponsored segments, and I'm sure you also are. But I got forced to do this, so let's get going.
Hello, Monitorama, and greetings from Stockholm. I really wish I could be there in person to say this, as Monitorama has a really special place in my heart. It was so central to the start of my journey with Grafana, and it was my introduction to the monitoring community. The excitement and positive vibes I got when I presented Grafana back in 2014 really cemented my decision to quit my job and work full-time on Grafana, which is now, like 9 years later, still what I'm doing, hacking away at Grafana, now with a huge team, to make it better. I still see so much untapped potential in Grafana and in the observability space that makes it such a fun project to work on. I just want to end with one message, and that is to keep the monitoring love going is what made me want to work in this space. Until next time.
So, I'm going to spare you the thing asking who here uses Grafana or knows it, but I did find one person who didn't know what Grafana was. So yeah, basically, I don't have to tell you too much about Grafana itself. The one number which I find super funny is the 20 million active users, which is more than quite a few mobile games, but we are not in that space, so that's kind of funny. And the reason is the Big Ten philosophy. If we did a survey recently, and there's more details, and there's a QR code on the next thing, and you can just pause the video and go there if you really care. But the main takeaway here is most companies, over 80% of users have between 1 and 15 observability tools in their portfolio as of last year. So you're never going to have that one thing and that one thing you migrate to. It's always going to be a mix, and we need to support this. Again, once the video is out, just take this QR code. But we don't only have a lot of backends, we also have a lot of integrations. What are integrations? They're basically more opinionated things on top of the data sources. There we do take the data which is coming in, and with our experience and everything, we build things for you so you can get stuff which one click. Like Kubernetes is the most used one next to the Linux one. It's literally one click in Grafana Cloud, and you can just see all the dashboards which we pre-built. You get all the alerts automatically. You don't have to actually do this for yourselves. And this is this underlying strategy of what we do. Yes, everything is open source, or most of what we do is open source. And with the LGTM stack, logs for log, or log for logs, Grafana for graphs, Tempo for traces, Mimir for metrics, you can do all of this yourself, and it's fully composable. You can also compose with competitors, because we do actively support them. But on top, we make it easier once you are in Grafana Cloud, if you so choose. There's also a bunch of other things. We have alerting, which is basically taking the Prometheus alerting and even the alert manager, and speaking as a Prometheus team member, this is kind of cool, fully integrated with how Grafana does its alerting. Going from there, on-call, which is basically your thing on the cell phone and doing the routing and doing the scheduling and everything down to incident, which allows you to really follow through on your incident, and once it is over, gives you a template for your post-incident review. It has integrations with Slack, with WebEx, with Teams, with whatever, to just do all of those things which you actually want to happen. Case 6, you can just test pretty much everything as long as it is an HTTP endpoint. Yes, most people use it for load testing. I personally much prefer the API contract validation, where you can move at pace and still ascertain that we are not accidentally still breaking any API contracts with any users or similar things. Okay, Faro hackathon project for basically end user monitoring, fully in JavaScript. Periscope, if you missed this, we started Flare, we bought Periscope, we merged them into Grafana Periscope. GA is going to be soonish. One of the hackathon results, the keen observers will see something on the right, which is pretty cool, I dare say, for something in the profiling space, and I don't think anyone else did this up to now. And the final thing, in Grafana Cloud, we have adaptive metrics, which actually allows you to massively save on the amount of metrics, and I dare say we are best in class in this. We invested massively over the last 1.5 years and had a really good team on this for the whole time. This is best in class, and we don't shy away from any comparisons. These are our own internal numbers from a massive data set. One customer had over 80% in savings. That's it. Thank you.
All right, thank you, Grafana. I still remember the many years ago when we were all sitting in this auditorium when Grafana was shown for the first time, and I don't think anyone who here remembers using the original like Graphite web UI, right? And then seeing Grafana for the first time, I mean, it was we were just like, yes. And I think we were all like, we know there's VCs in the audience. Please give him money, which they did. So thanks for that. All right, our next sponsor is Site 24/7.
Right, hi, I'm Gautam, one of the product experts from Site 24/7, and good to see all of you here. And I mean, for the past 3 days, so we have been discussing about the observability. I believe everyone would have been like familiar with this term observability multiple times, right? So any system that is observable, I mean, we can get the metrics from those systems. So very well, like we can pull the data from those systems and we can show on our UI. It's not just about the observability alone. So going one step forward, it is important that you have to analyze the data that have been observed, correct? And that doesn't stop there. So if you take a DevOps or like an SRE, so they expect seamless automation, right? So they don't want to do anything manual in today's world, right? So that is where they expect the logs, metrics, and the events and everything on a single UI, and analyzing the data. They also do the automation that has to be done by the product that they are using. So that is where Site 24/7 will be useful to the experts. So those who are like analyzing the data, and also those who can do the seamless automation. All right. So here in Site 24/7, let me tell you what is the width of our product. So this is like a key point about Site 24/7. So all the data that you require can be found in the single pane of place on a single dashboard. So you don't have to go through like different channels for you to, I mean, let us say, take a use case. So where if an application team wants to do the analysis or get the logs, so they will be like sending an email to the security team, and there will be like a thread going on, and then they will be requesting the logs from them. So it will be taking like at least 2 hours or 3 hours to go through all this conversation. And after that, they will be doing the analysis. And the MTTR, the mean time to resolve the issue, or that will also affect the productivity, right? So that is where if you can have like all your application team or the security team or the IT team, all your teams can be assembled on a single UI. So that they can have access to the logs, that they can have access to the metrics collected from the different resources on a single stack or the entire stack, and also they can also do the traces collection on the single UI, and they can do their analysis easily. So let me show where we have started. So we have been in the market since 15 years, so like since 2006. So we started with the basic website monitoring. So where we will be like doing the availability test for a website and getting the response time. So that is where we started. And then we expanded to synthetic monitoring, where you can like record a transaction, and you can we can simulate that transaction from our location servers. And then we started monitoring the entire infrastructure, let it be traditional on-premises or cloud. So we also support the multi-cloud monitoring that includes AWS, Azure, and GCP. So everything on a single platform. So if any, let's say CSPs, cloud service providers, would like to offer the monitoring services to the end customers, so a tool like Site 24/7, so that so if you take AWS or Azure, they do the siloed monitoring, so they won't be like providing support for Azure or GCP. So but coming here to Site 24/7, you can do that multi-cloud monitoring and offer the monitoring services from a single product. All right. So this is our server monitoring, and this is the overview dashboard. So on the summary page, we'll be providing the maximum of information with which any engineer can start their analysis. All right, and then we can also do the processes monitoring and everything, and you can get to know how much utilization or memory is utilized being a single process. That one, we don't stop there. You can also monitor the entire stack, and the data matters the most with our out-of-box plugin integration, so where you can do Postgres database monitoring, MySQL monitoring. That doesn't stop there again. So if there isn't any out-of-box support, you can write your own custom plugin script, and also you can monitor that using Site 24/7 plugin feature. And we have like IT automation. I mentioned about the thing of automation, right? So after analyzing, it is important to automate things. So if there is like any outage, or if there is any performance issue, let us say a disk utilization problem, you can use our out-of-box templates, so that once the threshold is breached, automatically that you can use a server command IT automation to execute the command, or like you can move the logs from one place to others, or reboot your server using our agent. So this is our inventory dashboard for AWS.
This is
and
where
the
I awkwardly
metrics.
stand here.
All right, and also we have a real user monitoring, where you can monitor the application's performance in real time, and we have a logs monitoring. I know the 5 minutes is not enough to show our entire dashboard, but I just wanted to show the width of our product. So anyone who would like to, our different teams, so who would like to use our product, so we have like different modules, so who can try our product. And this is the place where you can contact us. So this is our email address. If you want to make a note of it or take a photo of it, you can do that. And along with that, we have like CloudSpend, the cost management tool, and the status IQ page, where you can show the status of your resources to the end users. So that's all about the Site 24/7, and thanks for your time.
Awesome, thank you so much. Appreciate it. All right, and we are our last sponsor here before our final talk of the morning. Remember lunch party in the Slack if you're looking for lunch ideas. If anyone has some good light food ideas, like a salad, drop them in there. I'm asking, just for a friend, right? That would be very, very helpful to us. Alrighty, let's give a big round of applause for our last sponsor, Last9.
Hey everyone, I'm Nishant. I'm the founder at Last9. We build tools for improving software reliability. You all know about these problems. You all know why they're important, what needs to be done, and why do they exist. We don't need to talk again about why high cardinality and a sudden explosion of the data can cause our systems to go down, or managing the toil and upkeep of the Rube Goldberg of our metrics infrastructure, or being sort of concerned about how do we solve for that one query that's going to generate concurrency challenges when there's a massive dashboard being loaded as well. All of these are important, but what's missing, in our opinion, is we do not have enough control levers to manage this set of data. The only way today we sort of probably go back and think about this is doing instrumentation control, asking developers or teams to say, what can we do to make sure that we can reduce that cardinality? Or what can we do to make sure that all the apps, while they're being monitored and sort of observed, don't cause challenges on our existing in-house metrics infrastructure. But we don't think that's enough, because you really need control mechanisms across the pipelines on things like ingestion. If you could do for some of these high cardinality data, streaming aggregations, or understand which team caused it through team isolation or an app that caused it. We really need those levels of levers to be able to manage and run these data sets. Or similarly at storage, over experience, what we have seen is about 70% of our observability data is not a usual access pattern, while we have dashboards and sort of alerts. Most of the data remains unused, while it's important for one of that debugging session at 3 o'clock in the night. Most of it is not usually accessible. But then what does it mean for cost and sort of being able to scale it not just linearly? Could we store it in a Blaze tier, which only looks at most important use data, store it there, while the rest of the data could be provisioned on other cheaper storage mechanisms through a hot, cold, or an archival storage? But having those control mechanisms and a policy to sort of define that is what's missing, and it sort of addresses that, not having enough data controls. Or an overflow lake for certain high cardinality burst, right? You have certain high cardinality coming through, we don't want the system to go down. There's at least an overflow lake where you could inspect, look at what's important, and sort of deploy a streaming aggregation to solve some of these. Similarly, at a query layer, where you would want to ideally separate what and not cause concurrency issues when, like I said, an alert manager is accessing the same set of data that your Grafana dashboard is probably loading. You want client separation, you want access to data that is independent of those lanes and sort of a quality of service that's maintained for the client separation. Now, having all of these controls becomes extremely crucial. And on top of that, you also have something called as macro support for PromQL queries that allows you to do standard mathematical functions like percentiles and everything else as part of that macros itself, so that not everybody has to sort of think and write them and make mistakes in being able to build those. Finally, alerting, obviously being able to plug into using existing Grafana dashboards or being able to have events and metrics based alerting becomes extremely crucial, especially for scenarios like where today a typical alert would be like a 5% drop in availability. But what if you could essentially afterwards get a 5% drop in availability after a service deployment or after a service restart? Being able to correlate all of that together in a single pane becomes massively important. This is exactly what Levitate, the product that Last9 has, solves for. It's a managed metrics and events warehouse. The likes of Disney Plus and a lot of other customers who use it today have been able to save massively on the cost, primarily because of the bring your own cloud model that allows them sort of have control over their data, but at the same time have a control plane that lets them leverage and understand their data in a way that's best used for what they know about their systems. Finally, lunch plans. We're hosting lunch at Shake Shack. Food coupons and demo for the product is on booth J, the Last9 demo booth. Would love to show you guys and sort of hear your thoughts on it. Thank you.
All right, thank you, Last9. All righty, well, our next speaker is getting all plugged in and set up. For those of you who don't follow me on the social media, may not know, I've been doing this video series where I have people pronounce tech words, right? And we often like read and write. And so there was one specific word that I still believe is kind of fake news, so I'm going to take a very quick poll of the audience and just someone shout it out if you will pronounce this for me. But does anyone know what a JSON web token is? Ever heard of that before? So, yeah, how would it's JWT. So how would you pronounce that? Yeah, you say that like that's a reality, right? Jot. So someone, I actually, in research of this one, someone had said JWT. Is that like a Java web toolkit? You know, this was obviously someone on the older side of remembering what a Java web toolkit was. So I was like, yeah, you're right. And I went to go look it up to see what that was pronounced. And Wikipedia claims that it's pronounced JWitty. So I think that Auth0 really kind of mailed one in by not just adopting the JWitty pronunciation of Jot. So anyway, with that being said, I'm really excited for this talk because there's two things I love, which is cloud cost management and observability. Yes, I'm a giant nerd. It's really fun stuff. And so let's give a big round of applause for Emily.
Thank you. I'm so excited to be back at Monitorama. It's one of my favorite conferences, and I think I spoke here in like 2016, and so it's like been a little while, and it's just like so nice to see you all again. I'm really happy to be back. Talking about a talk that I also think is fun, so like Pete and I will be at that table by ourselves, and if you want to join us, you can. My name is Emily Nakashima. I am the VP of Engineering at Honeycomb. I might mention some links in this blog post or like things you might want to learn more about afterward. And all of those will be collected up at this URL. There'll be a QR code at the end. And I'll also try to drop the link in Slack. So if you hear about something and you're like, want to know more about that, there will be links if you're not. Different stage companies think about cost differently. So just a little about where I work. Honeycomb is a SaaS observability product for software systems. For today, weirdly, the observability part of it actually doesn't matter very much. Like you can just think of it as a SaaS product. You do need to know that we are building something sort of moderately complex, and we have a reasonably high throughput cloud native software system, but other than that, those are really the big pieces that matter. The more important part for this talk is that we are a Series D startup. We have about 160 people. Our engineering team is about 50 people. We have a highly technical product. We have customers that we like a lot that use that product, and because of what our product is, we have traffic that can be highly variable, but it has some patterns and trends to it that are pretty clear. Everything I'll say about observing costs can be done with a range of observability products, like both paid and open source. So if you have tracing and metrics and you have a way to receive alerts today, you probably have everything you need to do the things I'm going to talk about. Will this talk be cloud vendor neutral? AWS is our preferred cloud provider. We have been there since year one. We know a lot about running on AWS, so there will be some AWS-flavored stories in this talk, but I think these principles apply no matter which cloud vendor you use. So hopefully there'll be something for everyone. I'll just say, I know it's day 3. I'm right before lunch. Some of you may be struggling a little bit. Just in case I start to lose you and I start to look like a ham sandwich to you, I'll just share like my most important point up front. So many of our teams work so hard to build proficiency at managing system properties like reliability, like performance. Cost is a system property. It is also correlated or inversely correlated with a lot of these other system properties as they are with each other, so it needs to be balanced. And we should use those same hard-won system skills for cost rather than what a lot of companies do, which is like silo it off as some separate concern that you don't think about very much. The most important skill I think we actually need to do that well is probably observability. So this talk covers things Honeycomb did from sort of seed stage to Series D. If you are a giant company, if someone in your organization is FinOps certified, if you are a founding member of the FinOps Foundation, I am excited for you, and I don't understand you at all. You are very confusing to me. I think your teams can still do a lot of the stuff I'm going to talk about, and you probably have a more sort of structured process for this, and that's great. Like, you do you. This talk is not FinOps certified. This talk will cover 4 cost management scenarios that we live through, not all of which make us look smart and cool. Some do, some don't. And then somewhere in the middle, I will talk a little bit about how to cultivate your inner COO or VP of Finance, basically how to think about costs like your exec team does. So part 1, here we go. Yes, I'm baby, unfortunately. Let's go all the way back to 2019. I know nothing. I've seen an AWS bill before, maybe, but that's it. I am about to become semi-responsible for our AWS bill in that way that like hilariously happens at startups where like nobody tells you you're responsible, but all of a sudden like nobody else seems to be responsible and you're like, oh, like something is wrong and I need to go look at it, right? So I'm about to learn a lot. We did at least do the basics. So I won't talk about these a bunch because these are like, you know, doing your chores, but we did most of these. They are necessary but not sufficient. So we turn things off. Like, don't leave expensive, weird stuff running. The like dev environment that someone set up in like US West 2, like go turn it off. Tag everything. Consider your cloud provider cost-saving suggestions. It might not seem like they're there to help you, but they are. They really are. Use reserved instances and now savings plan. And then, you know, your cloud provider probably has programs to help you be successful, go faster. Those are good. We were doing all that stuff. We weren't large enough yet to have an enterprise discount plan, which is like a large overall commitment over multiple years for a discount. We did do that as soon as we were eligible, but we weren't big enough. We also were not interesting enough to like work with a cloud cost consultant, which we did down the road as well. And we've never used a dedicated cost management tool and don't intend to, and we'll get to why in a second. So here's where we started. Once every quarter, someone would go, oh, hey, like we haven't thought about the AWS bill in a while. Like maybe we should go look at the console and learn some things about how we're spending money. And that person would sit down and they would put together like a really nice prose narrative about our cloud bill and a nice document with some graphs. And it would be things like, well, write traffic costs 10 times more than read traffic, or, we spend almost nothing on data storage. It's like retrieving that data for querying that costs a lot. And this like sounds like a bespoke small company approach, but interestingly enough, we still do this to this day. The thing that we learned through this is like engineers actually need like prose about cost way more than they need raw numbers. Like they need those like lines that stick in your head to help them make decisions. We have changed what like the backing data is for that. So sometimes we found that the console was not really enough to understand what was costing what, and we noticed something interesting where we were like, hey, structured logs and traces are like just keys and values, right? You know what else is like just keys and values? That's right, that giant CSV cost and usage report that you can get out of the console. So we fed that into our tracing tool, and now we can sum and break down by tag or instance type. You talked about high cardinality. Guess what's high cardinality? It's tags. And the only real downside to this is like these reports are not real time. It's also a very large CSV. Two downsides. They are mutable and they can sort of take a day or more to finalize. And so we wouldn't do this today because this data is like just a little too laggy for what we're trying to do now. But in the first few years of the company, it was huge to have this information in the same place that engineers looked at every day. We were too small to have those folks who could sort of be the experts, who could like translate what you were seeing in the console to your real world. And if we just put it in our observability tool where we already were, like engineers knew how to self-serve those insights and they could sort of reason about cost by themselves without needing someone to help them. One thing I did learn the hard way, measuring cost can have a cost. Yeah, like calling your cloud provider's APIs can have a cost. And that probably includes some of the endpoints you'll probably hit while like doing cost analysis, especially if you're trying to like automate cost analysis. Nothing makes you feel sillier than accidentally spending a butt ton of money by mistake when you are trying to do cost analysis. So just like keep that in mind if you go on this journey. All right, so luckily at this time, our costs were kind of relatively boring. All of our services are named after dogs. That's a long story. Find me at a happy hour if you want to know. But a really simplified view of our system looks like this. On the left, this is like our data ingest traffic, and we have like relatively high volume, but like also predictable traffic. Like there's very clear patterns throughout the day and the week. Customers send that telemetry data from their systems, and we kind of like know what that's going to look like. That API service sends data to Kafka, which makes it available to our query and storage engine for persisting. And then over here on the right side, we have unpredictable traffic to our web UI, but it's quite small compared to that data ingest traffic. So it was small enough that we didn't really have to think about it a lot from a cost perspective. That service talks to our query engine behind the scenes, so that's how the whole thing kind of like fits together. So we decided it would be cool to build a service that did tail-based sampling for traces. So that's, of course, going to go in the data ingest path. There she is. Yes, we called the service Dalmatian. And when we were architecting the service, we intentionally wanted to spread sampling operations out across multiple availability zones, which makes sense, right? If we lose one AZ, we still want some telemetry so we can figure out what's going on. And what we really want are whole traces. So we need to have some logic for pushing the right trace IDs in the same place so they sort of cluster together. So let's draw this right to represent that. Great, cool, so we did that. One thing you'll notice if you look carefully is that all of a sudden we're sending a lot of data across availability zones to make sure it lands on the right partition for sampling. So that just increased our costs. And of course, this is a sampling service. So now that we got all that data in the right place, we're going to throw a bunch of it away to perform that sampling. Doing great, doing great. So the DocBill group, who we actually hired later to help us with this problem, made this great chart that explains what happened to us. Yes, this shows how AWS bills for data transfer. And there was one of those arrows that we just didn't think about quite enough. If you spot the arrow, you win a prize. Okay, there's no prize, but try to spot the arrow anyway. And it's easy to do if you have spent 9 hours with the AWS docs or you live inside Corey Quinn's brain, which is not everyone on our team. All right, so we knew about data transfer costs. We just didn't know about them hard enough. What did we learn here? We have a known known. And with cost, known knowns still matter. You can still hurt yourself with them. So we have to make sure our teams read the docs, tag resources, actually use the provided cost tools from our cloud provider, and sort of keep on top of that stuff. I'm going to just pause here for a brief. This is the how to think about costs like an exec. We're really lucky to be able to hire a super talented team of engineers, very high autonomy. They don't just take orders from above. We really want them to go use their own judgment and use that context that they have to go build great things. And one thing that became really clear to us on this journey is that we really have to provide those folks with a lot of context on how to think about cost to do that job well. So some of us are old enough to remember 2021, a long time ago. It's very different now, obviously. Like, it just like feels really different out there. I know a lot of companies have been through layoffs this year. Some people may be job hunting. It's a hard moment. And I think a lot of us are experiencing a little bit of whiplash, right? If you were a venture-backed SaaS, you probably heard the message like, hey, you should grow, spend to grow. And that message started to shift a little bit in 2022. And then like all of a sudden, now in 2023, investors have like really changed their tune, and all of a sudden like efficiency matters quite a lot, and we're getting this message of like, hey, why weren't you efficient all along? Like, oh, okay, cool, I'm gonna think about that. So we need to help our teams with this, and we, the observability people, I think are like the best position to help with this problem, especially if it's a little bit newer to your team, to kind of think with this mindset. We're great at doing scarcity. All right, so it was time for cloud cost education. So what do we tell our teams? There's really only 3 costs worth thinking about. For us, it may be different for you, but for us, cloud cost. Sometimes that includes some of the bigger vendor costs, but really cloud cost is the big, the monster slice of it. Salaries, people. We don't try to optimize that one too much. We just sort of think about how much we cost. And then the weird one that we're actually all kind of bad at dealing with is opportunity cost. Harder to think about. We have to remind people, hey, if you spend a day optimizing the cloud bill, that's a day you could have spent building a new feature to differentiate the product or delight our customers. It's obvious when you say it out loud, but it's still really hard to know kind of how to weigh that against other things you would do. I found that actually comes off way better if you have some non-engineering experts that will come and tell your team that versus from me. So this is Honeycomb VP of Finance, Chris Wozniak, and our COO, Jeff Gray, in their natural habitat, which is a Zoom call that has spreadsheets. And they are great at helping our team understand how to think about that opportunity cost piece and talk them through specific trade-offs and provide examples. Not all finance teams are great at communicating this stuff, and sometimes you just sort of get the message like, hey, don't spend money. And I think if you're in that situation, it is worth going to ask them some specific questions to see if you can get more granular advice. So good conversation starters might be like, hey, how do we weigh the opportunity cost of working to cut spend versus shipping new features? What cash burn rate are we targeting? Like, are we on track? How much are you freaking out right now is also a good shorthand for that. You could also say, like, hey, when you look at the engineering budget, what do you worry about? I think the number one thing you'll hear back is surprises. So our engineers know that by now, and when they start to see a change in any of our cost curves, they know to go proactively tell finance, which is a really nice pattern. And then, like, last but not least, how do I value a discount today against paying up front for like either a longer commitment or putting all the money down right now? And those answers can change relatively quickly as sort of the conditions of your business change. And then we also want to know, like, what does good look like from their perspective? Generally, for our business, we want our COGS, our cost of goods sold, to be correlated with our annual recurring revenue, but growing at a slower rate. So those curves have a relationship, but they're slowly moving apart. Sometimes, like, naive finance teams will push on you and just sort of say, like, don't spend it all, or like, make the COGS curve flat. And like, unless you're running like a Ponzi scheme, that's like generally not super realistic. If you have a real product or service with real users who are getting value, that usage is going to grow over time. The thing you really don't want is for the cost curve to become steeper or grow faster when the revenue curve has not changed, right? That's bad. That's when you get the DMs from the finance team. I know this sounds really obvious, but like some engineers don't know that going up is fine as long as the rate is the right rate, right? So it can be useful to visualize it. Our finance team has also been really great about helping us understand industry data to benchmark. So public companies in this space hold earnings calls and they release information about their businesses, and we can use those benchmarks to kind of know what good looks like. So things we could ask are like, how much do companies spend on like engineering, product, and design versus sales and marketing? Or what is their cost of goods sold? What is their margin on the software they're selling? What are their earnings targets? How are those changing? How are they planning to grow over time? And sort of being aware of that stuff, we can build our fluency with what good looks like beyond just the walls of our company. So I started to write this talk, and I was like, engineers are bad at valuing their own time. it's like sometimes true, but I think that actually places the fault in the wrong place. Yes, if you make $200,000 a year and you spend all day on a cost optimization that's going to save the company $300, that's a math error. Like, don't do that. But beyond that, I think people actually need a lot of business context to value their time correctly from one moment to the next. The value of an optimization can change depending on business conditions, and engineers don't usually have an easy way to sort of follow along with those things, right? So what we learned is like engineers need a lot of context to correctly make trade-offs in cost. And we want to give our team like the simplest heuristics we can to kind of evaluate these things. So tell people, hey, one engineer's time, it's like $1,000 a day. As a startup, remember that our most constrained resource, our most precious resource is time. Money might be second, but time is probably first. And if you think you can win a new customer or build a differentiating feature, it's probably going to be better to do that than to shave away at the cloud bill, unless you can go like take a 6 or 7 digit number off that bill somehow. And then finally, cost-cutting investments should have like a payback period that makes sense for where we're at. So we probably want to see those payback in under a year, absolutely. Ideally, probably under 6 months. So giving people that time horizon, and it can change, is a useful thing for people to sort of tuck away in the back of their minds. I ran into a really stark example of this whole situation the other day. Like one of our SREs was like feeling good, and he told me, hey, I just signed an all-upfront compute commitment, and I saved us 3% per year. And my heart just sank. I was like, oh no. This used to be such a good idea. Like in 2019, this would have been the hotness. But now we could make more money, like leaving that money just sitting in our bank account. And I know that because I am in meetings with our exec team where we talk about our finances and we like talk about fun topics like interest rates. He is not in those meetings. How is he supposed to know that? So I need to make sure our whole SRE team who are buying things in the console have the right information. If you're an engineer and you don't have this information, I think it is totally fair to go ask your business stakeholders for it. If you are a manager, track people down who can give you this information and tell it to your team. I think you'll be surprised what people do with it. All right, back to my stories. So story 2, our product uses a custom distributed column store. If you aren't familiar with a column store, here's an example. Don't worry, we don't really store social security numbers, just an example diagram. It's kind of a database, but instead of storing the data in rows, all of the values are stored as columns together, right? So column stores typically deal with sort of wide but sparse rows or events well, and they can perform aggregations on columns of data fairly efficiently. Like, for example, if you wanted to generate a time series from a column of timestamps, that could be quick. A column store, or our column store, which we call Retriever, has this concept of partitions. So, if you are a small customer, you don't need that many partitions. We will just sort of put them on a few, put your data on a few. If you're a medium-sized customer, we're going to spread you out across a few more partitions. And if you are a large customer, you will actually be spread across every single partition in our fleet. You'll be everywhere. When a customer runs a query, all the host partitions that contain their data participate in calculating the result, so they each do a partial calculation against just the data that they have on disk, and then there was some lead that was elected, and that host will aggregate all those partial results together and then return them back via the API. So here's the part that really matters for cost. These instances are really beefy, and they use a lot of compute and memory and storage, and they come in a fixed size fleet because this is stateful, right? So we don't want to auto scale it up and down. So lots of beefy hosts all together, and they're paired up for redundancy. So this is a relatively expensive part of our infrastructure. So the column data is stored as files on disk on these instances, but we wanted to be able to offer more data retention to customers, and we didn't want to scale this whole expensive beefy fleet up just to do that, right? So we came up with an idea of sort of a tiered storage setup, and we started moving older data to S3 for longer term, lower cost retention. Seems like a good idea. Ian Wilkes, who is the lead engineer on our storage engine, looked at this architecture and said, hey, we just distributed our storage. Do you know what else we could do? Maybe these hosts actually aren't so important anymore. What if we had infinite hosts? So we started fanning these partial calculations out to serverless, to AWS Lambda, and we were sort of able to dramatically parallelize calculations that way, which is really cool because it lets us handle larger amounts of data with sort of similar query times without sort of linearly increasing query time or something. But of course, what's happening behind the scenes? I told you about our boring traffic. That had really shifted a bit since then, so we still had that high volume, predictable data ingest traffic. But our read traffic had actually increased a lot, and it was still unpredictable. So it's interesting, these two variables together. A cool thing about this architecture is that we now have a system that could be a lot less expensive when it's just sitting there idle, right? Like the Lambdas, you don't pay for them when no one's doing stuff with them. And we don't need to make that like fixed size fleet bigger and bigger to kind of handle a certain like peak traffic load, right? But serverless Lambda is typically going to be much more costly per unit of compute than a sort of traditional cloud server setup when you're actively computing. So like, how much does it cost now for us to do this? We have no idea. This is a known unknown for us. And you know, we already had some good techniques for dealing with those kinds of things. So enter observability. All of these Lambda calls were already instrumented with OpenTelemetry, so they appear as spans in our traces. Maybe we can use those spans to calculate cost, right? Yeah, turns out we can. You are billed for your Lambda usage by how long the Lambda runs. And that actually turns out to be the same thing as like the duration of the span you just instrumented. So we can make a calculated field, or if your system doesn't support those, you can actually just add this to your instrumentation directly as a calculation. And that takes the price per second that the serverless compute is going to cost, and it multiplies it by the span duration to get like how many dollars you actually spent to run that Lambda. And then in our metrics tool, our tracing tool, or whatever, we can aggregate those values and sum them up, and then we can like put a dashboard on the wall that says like, hey, we spent this many dollars today running these queries. You know, we break them down into groups by like which sort of source they came from within the UI. And of course, we can also even make alerts on those. So we send ourselves these like low priority alerts when Lambda costs exceed a certain threshold. The threshold differs for different query sources, like you know SLOs or manual queries. But it's just sort of a way to see how much we're spending. Generally, like, these don't hit on call, but like if a manager sees a bunch of them go by, they'll go make a ticket, and then the team will spend like the next week thinking about cost. So for known unknowns, we want to deal with those with the same tools we already know quite well. Custom instrumentation, some simple alerts, things that we are already doing day to day in our observability practice. All right, last or third, it takes a map to navigate costs. There have been some great discussions of all the knowns and unknowns in this conference, and I wanted to come back to this like funny category that we don't talk about as much, which is unknown knowns. We talk about these at the individual level, so I as a person have these unknown knowns of like things I don't consciously know, skills I've had for so long that I don't think of anymore, implicit biases, instincts, deeply assimilated knowledge. Unknown knowns can also exist at the organizational level though, right? If something is really well known and obvious in one part of the company, but unknown and needed in another, that is an organizational unknown known. And unknown knowns make the finance team sad. So I've had this exchange a number of times, and I realized I needed to fix it. The finance team says, hey, you know, budgets are tight, but our current cost curve looks good, so we just need to like maintain this for the rest of the year and everything will be okay. That sounds good. Then over in engineering, engineering is planning to ship a butt ton of new features, and every single one of them requires running large batches of queries over lots of data. So these two things are on a collision course, but people don't know it yet. Now is the time to go make some friends. We ran into this last year when we were working on a query-heavy feature. We wanted to build like a map visualization, and we wanted it to do some querying behind the scenes to sort of aggregate what it was seeing across multiple traces. And we were really worried this feature could be very expensive, like potentially so expensive that we like should not even build it at all. And so we really wanted to like get this right early on. Luckily, we had a plan. Here's the core team that built this feature, and they knew about this cost concern that the business had, and they also wanted to build like reliability and scalability in from the start. And so here's the plan. Yep, that team has an embedded SRE, who is Lex. He has a great newsletter, if you know Lex from the internet. From day one, Lex started working with them to help them model all those things and make good choices and balance all those factors together. And so before they were even writing production code, they were already putting together design documents and discussing cost mechanics and making sure that like they really started on day one with that as part of the process. And then as they started to roll this out in the early access program, they measured the traffic relevant to those services to make sure costs for customers of different sizes were acceptable. This is by customer plan type, so we want to make sure that like if we are spending a lot of money, it is for the big customers that pay us a lot of money. That was a good thing to be able to validate with our instrumentation. And it was nice to be able to do that before this was even like out in the world in past beta. So how do we deal with unknown knowns? Of course, we just saw there, what we want to do is get people talking early. For us, that's product engineers and finance and SREs all collaborating together from the start. But I also learned something that really surprised me that I thought was really exciting. We thought that those narratives about cost would be mostly useful to those stakeholders. But what we actually saw is that they are like broadly useful across the whole company. When you can have like a few quippy sentences that summarize how your costs work, this information starts to pop up in places all around the company that you wouldn't expect. Product management, design, sales, customer success. People innovate using this information. They dream up new features that they didn't realize would be viable. They come up with new pricing and packaging ideas that solve problems for our customer that maybe they didn't think we could solve. And they do really cool stuff once you just sort of give them the context. All right, last example. That was cool. We really nailed it with that one. We're feeling really good. But this stuff is cyclical. So we have to learn new lessons, and we have to relearn some old lessons from time to time, unfortunately. Here's a lesson that speaks for itself. We now have a policy to use remote pair programming or screen sharing over Zoom when purchasing reserved instances. One person says, hey, I'm going to purchase this, and the other person looks at it and confirms before they click the buttons. You can guess exactly where that policy came from. And then you can feel a little sad with me. Just a little. On the positive side, here's a good one. We had been optimizing for a while. I thought we would never see another big bang optimization again. You know, as you do more and more of this work, generally the optimizations get smaller and smaller. But our field CTO, Liz Fong-Jones, totally proved me wrong. She began experimenting with migrating from x86 chips to Graviton 2. One thing we learned there is like, hey, technology is always moving forward, and sometimes the future is less expensive. So now we've migrated as much of our compute to Graviton as we can, and we've seen improved performance and about 30% lower costs for some of our largest workloads, which is really, really cool. That change didn't take a huge amount of work. You do have to recompile things for the new chips, but that work was, importantly, it was parallelizable and non-blocking, so we could continue to do feature development at the same time. Because we already had good instrumentation on key systems, we could also verify right away that that had actually had the intended cost consequences that we wanted. So just like performance optimization, you think you've done a great one, and you need to go verify in real life because sometimes you didn't actually make something significantly faster in the way that you expect. Cost optimization works the same way. We already had good instrumentation on these systems, which was really helpful, so we could confirm that our quick win was really a win. So here on these graphs, you can see the purple line is for the Graviton chips, the orange line is x86 chips, and you can see those bottom two are P99 and P50, and you see that the Graviton usage is consistently lower, meaning that for those workloads, we probably can actually run fewer instances, which is nice. Even more important than that, you want to ask, like, what does it do for the end user experience? Like, wouldn't it be better to have fewer instances if it was actually slower? Well, we saw that P99 and median latency both improved by about 30%. So that's amazing. Like, we've reduced cost, we have also made the experience better for our users, and we've been able to do both of those things at the same time without a huge amount of work. Big win. But it's a roller coaster. Just when you start to feel smug, I saw this conversation go by in Slack. We tried to test something out. This wasn't even doing real work. We were just going to test something out with CloudTrail, and we misunderstood how we would be billed. And we were sort of quietly racking up 5 digits of spend in the background while doing this test. I'm embarrassed, so I put a little fig leaf over the actual dollar amount. I will not tell you how much it was. And we only turned it off because we got lucky, and an engineer noticed that there was like this large bucket growing for no reason. So that was not great. We're going to keep working at that. And it's just to say, like, even if you feel like you're building your practice of this, understanding and estimating cloud costs ahead of time can still be quite hard. We are now testing out our cloud provider's cost anomaly alerts to help with this. I'll say, as a company, we are big anomaly detection skeptics, but we actually think it can be useful for alerting on cost versus other system properties. Why is that? With cost, there's no need to make inferences about like the thing that we really want to measure. Like usually we are trying to measure user experience. We're trying to look at all these other signals to do it. In the cost case, we are trying to measure cost, and we can look at cost to do that. So we think it's much easier to actually get useful, actionable alerts. We're trying those out. So now we've filled in the whole quadrant. We've got those unknown unknowns. For those, we want to instrument all the things. And we really want to use our observability practices that we've also already built. And then maybe we can have a little anomaly detection too as a treat. All right, what did we learn? Cost is just one more system property. We know about managing system properties. There are benefits to using the observability tools that engineers already know how to use and look at every day. Business context is essential for engineers to make the right cost choices. And if we make friends with the finance team, the whole company might benefit and be able to innovate more. And last but not least, we want to start by considering cost before that first line of code is written, just like we do for reliability and scalability. All right, like I said, if you want these slides or if you want longer prose descriptions of some of those projects, those are all at that URL, or you can scan the QR code. I'll also try to drop the URL in Slack. Find me if you want to talk about this stuff. I always love talking about it. And thank you so much for listening.
Fantastic. Emily's such a pro that the timer is literally at 1 second. That is how polished this is. We've got a couple of minutes, though, for questions, though, before we break. Any questions from the audience? Any finance people? Oh, I see. There's two. So we'll do the slightly that way person.
What is, you've got actionable cost alerts. Who gets them, and what do they usually do?
Who gets the actionable cost alerts, and what do they do?
Ooh, that's a good question. We have a Slack channel that's for like real stuff is going down in production, and they don't go there. We have a Slack channel that is called Signals. That is just like stuff we're sort of keeping an eye on to build our spidey senses. I will say the process for translating from signals to ticket to work done is not perfect, but enough people look at that if we've seen the same thing go by a couple times, someone will like make a ticket and then it will become like medium priority, but not like everything's on fire priority.
Great question. In the back.
So you showed the using land integrations for that calculation. What about, do you have any longer running like EC2 type stuff that you monitor as well? How do you track those costs? Is it just cost report directly, or do you have any tracing tie-ins?
Yeah, how do you track the more, I guess, generic EC2 costs?
Yeah, that's a good question. We use a couple different methods for that kind of stuff. Some of it we can instrument, and then when we sort of like build graphs that we share with our team, a nice thing you can do is sort of describe how to jump from some of the more like system-oriented metrics to costs. Like realistically for us, a lot of those are sort of not our most interesting or surprising costs, and so there hasn't been as much focus on instrumenting those well. But a lot of times it's a similar sort of inference where you sort of say like, how can I most approximate like what this would be and sort of send it out to people. We don't do it trying to use like a span or duration or something like that because those are running for a long time. But we will sort of find other ways to be able to like count them up and then show something in the UI that is like meaningful from a cost perspective. It's much more about labeling versus instrumentation.
Awesome, great. Any other questions? Anything from the top? All right. Well, let's give another big round of applause for Emily. We are at that time. It is time for some lunch. So we will see you all back here at 2 o'clock. Let's maybe like 1:50, We'll get this thing done. So 2 o'clock is when the next speaker will go in. A lot of great talks this afternoon, more sponsors, and then the raffle. And the raffle prize showed up, one of them. It's pretty cool. So we'll see you this afternoon. Hello, everyone. Welcome back from lunch. Who's feeling it? Yeah, sure am. Whoever, I forget who it is, and I apologize, dropped in the chicken and rice place. Thank you.
No, I was at.
Oh, did you go there?
I did. Great.
So I missed it, the chicken and rice place, it used to be a food truck. The line was always just incredible. Obviously there's no food trucks over there. And I didn't know that they actually had a physical location where you could just like order online and walk in and pick it up. It was an amazing experience. So whoever posted that, thank you. I was gonna get something light and I got chicken and rice instead. So this is where we're at. All right, we're gonna kick off the rest of the talks. We've got some talks, a couple more sponsor talks, and then we'll do another break, and then we're gonna close it out with the last two speakers as well as the raffle. Like I said, stick around if you have not put your ticket into the thing. I would suppose let us know, because I think Jason might have taken the box already, and you definitely don't want to miss out. There's a lot of great prizes. So, all right, with that being said, let's kick it off here. Big round of applause for Ivan.
Hello everyone. I appreciate I've got the after lunch slot on the third day of a great conference, so you're pleased to hear this is not a particularly technical talk. This is mostly about humans and human interactions, so hopefully not too heavy for you. So firstly, a little bit about me. I've got kind of 15, 16 years of experience in kind of monitoring and observability world, rolling out kind of various different types of tools, from infrastructure monitoring, log monitoring, RUM, APM, all the alerting and stuff like that. Mostly in big banks, large enterprises, right? And one of the biggest challenges I've faced is not the actual building of the tools, right? It's about getting people to use them, to instrument their own damn code, right? And actually, you know, use them in anger. And I've come to realize that these problems are very rarely technical. Okay, they're normally very human. And the talk is called this because someone once said to me, or I came across this quote, right, that developers are very creative problem solvers. And if you look like a problem, then they'll solve you too. And this really resonated with me, right? And I've spent a lot of my career trying to make sure that the adoption of monitoring and observability tooling and things, and actually using them, doesn't look like a problem to people. And then speaking to various people in our domain at conferences and everything, I've realized that, you know, it's not just me that's had this problem. So this talk is kind of sharing some things that I found that don't work, some things that do work, and hopefully it's of use to you. So yeah, creative problem solvers. Developers solve problems, right? And they often do it in really creative ways, right? It's kind of their job. They kind of train their brains to do so. And to be honest, it's really impressive. They face all manner of obstacles. Now, I'm not a developer, I never have been, but these are some things that I've heard developers say. So they start off with kind of business logic and stuff, and then they've got their legacy code and dependencies, depending on which language. They've got types. We're a Rust shop, so don't have that problem. Then CI process and everything else like that, right? And basically, we need to make sure that on the path to production, that monitoring observability tooling and the adoption of it and using it, it's not on this list of things. It's not another thing that they try and work around. So I used to be really naive, right? I thought that if we provided a monitoring service, we told people about it, they were going to use it, right? Because why wouldn't they use it? Monitoring is great. And if they kind of instrument their code as soon as they start writing it, then they can solve their bugs really, really quickly. It's much cheaper to do so before it reaches production. This whole kind of left shift stuff and everything. And it would be great, but that's, you know, not how it works, right? And the fact is that people will not start using things just because it exists, even if they know it exists, right? And these are some of the kind of reasons that I've come across. And it was actually quite kind of cathartic writing out these, to be honest. So yeah, the fact is that there are many reasons why people might not use this stuff. Some of them kind of understandable, some of them maybe less understandable, and everything else like that. And to be honest, when I thought about it, I thought it was quite ironic that for someone who's spent their entire career in IT operations, that I kind of thought that I would build it and it would be done, because actually I know that the building it is the easy bit. It's the bit after it, that comes after, that's actually much harder, right? And, you know, good intentions don't actually achieve anything. So we need to help these people, because fundamentally, we can have the best monitoring observability platform in the world. But if no one's using it, then we've kind of wasted our time, effort, money, everything, right? So the first thing to state, and it's kind of painful to say this, right, but I think a couple of people have as well. I was a little bit scared about this slide, but I think other people have mentioned it too, is that not everyone cares, right? Whilst we all here really are sold on the value of monitoring, observability, everything, and instrumenting your code, not everyone cares, and they don't see that value. And this used to make me really, really angry, right? It just used to drive me wild that people didn't see this. Why didn't they understand it? It was going to help them so much, right? But as I've become older, calmer maybe, wiser possibly, I've begun to realize that actually it's okay. It's understandable. And actually, it's really human. We're all different, right? And it's kind of wrong of me to expect that everyone would get it because I do, right? And they would understand it because I do. We're all different. And in actual fact, that's kind of why all of us in this room and on the live stream and stuff, that's kind of why we exist, right? We are the champions in our organizations. And we do need to sell the value of what we do to our customers because they are our customers, right? We kind of need teams to need us and use our tooling, right? Because if they're not, then we're not providing value to the organization, right? And fundamentally, for all of our tooling and all of these services, there has to be a return on investment on this stuff, right? If it was cheaper and easier for a company just to swallow that outage than it was to put in this monitoring observability, then they might actually well do that, right? And if it's hard for people who are writing the code to see the value in what we're doing, then, but we just become a control game, another obstacle, a thing to overcome, right? So we need to help people see the value. So my first kind of thoughts on this were, let's just automate all the things, right? Let's automate that pain away. Let's make it so they don't actually have to do anything, whether they like it or not, whether they know about it or not, they're going to get all the good metrics, right? We can build it into our pipelines, we can add all the auto-instrumentation, and they will get it, and it will be there, and that's the problem solved. But actually, what I quickly realized is it isn't the problem solved, right? If people don't know about it, if they don't care about it, what are they actually going to do when they go to need it, or use it, or there is an incident, right? Am I going to turn up to every incident because I know the data, because I understand what's being emitted? That's, it's not a very scalable model, right? I don't really want to be on call for everyone else's stuff because I'm the one that put in their monitoring for them and they don't understand the data. So we actually need people to consciously add in the instrumentation, right? We need them to know what metrics, logs, traces, and any other data that their services are emitting. As I say, without that, we're either signing ourselves up for a lot of pain, or again, we might as well not have bothered. So yeah, having the best solution in the world is pointless if no one's using it, but it's also pointless if no one understands it, or anything else like that, right? So the other idea you can do is you can kind of mandate things, right? You can force people to use it, yeah? Thou shalt, instrument your services. You must do this. Again, tried it, doesn't really work. Firstly, you kind of end up policing this stuff a lot, right? You spend a lot of your time trying to enforce these rules, and that's just not very fun, and I became angry again. Why haven't this team done this, right? They know they should do this. It's just not a very nice conversation to have with people. Going around, you need to do this, you must do this. You do not make yourself popular. I can guarantee that. So it's actually much better to have a nice, happy path that people want to take, right? Because they actually see the value. So how do we explain the value? I was speaking to a friend of mine about doing this talk and kind of explaining what I'm trying to say in this slide, and he went, oh, don't call the baby ugly. I'd never heard of that before. And incidentally, this slide is why I'm using words, not pictures, in my slides. Right, The point is that when you have a conversation with someone, the way in which you have a conversation with someone, the tone of voice and everything else like that can drastically change the outcome of that conversation, right? And the fact is that when people are writing code and developers are doing stuff, building stuff, they take pride in their work. They care about it, right? And no one wants to be told, hey, that's great, well done, but your stuff's going to break, right? It's going to fail, so you need what I'm providing. That's not a great conversation to have. It's not a very positive conversation to have. And, humans respond better to positive conversations. And I had this epiphany many years ago when I was quite young in my career, and I was speaking to this new engineering manager, very experienced, lots of knowledge and stuff, but they were quite abrupt, and I was kind of a little bit scared of them. And I went up to them and said, hey, you and your team, you need monitoring, you need all this stuff, because your stuff's going to break and it's going to fail at some point. So come and see me. And they just shut me down right there and said, we write good code. Why are you coming and telling me it's going to fail? Why don't you tell me you're going to show everyone how great it is? And I thought, I don't know. I genuinely don't know. That's a great point. So since then, I've tried to change my conversation, right? I say, rather than telling your stuff is going to break, I say, hey, you do really clever things. It runs really fast, right? Let me show the world how great it is. Let me help you kind of sell how brilliant you are at writing code, right? Because the fact is that 99.99% or whatever your SLO is and stuff, that's a high number. It's a lot, right? And when you think about it, these people are doing incredibly clever things, right? They're working with lots of different technologies. Microservices are making everything more complicated. And they have crazy mental models of how all this stuff is doing. That anything works at all, to me, is a wonder, because I certainly could not do it, right? So let's celebrate them, right? Let's take monitoring, observability as a way to show how awesome these people are, okay? This also works with product as well, I found, right? If you're finding that this is getting de-scoped, if it's never actually getting done, this is a great conversation to say, well, I'd like to show the world how many users your product is getting, how many times your new feature is being used. This is a much better way to have a conversation that is more likely to end up in success. Right. It's a tough job to do anyway, right? And it's a really tough job to do if you're by yourself. So you need to make friends. As I said earlier, right, not everyone cares. However, some people really, really do care. And some people have really crazy flashbacks from that time in an incident a while ago that they didn't have data. So they might not care, but they know they need to do it, right? And these people are your friends. If someone comes up to me and says, hi, I've got this Spring Bean that I like to monitor, as I said, enterprise banks, so Java, right? I remember them, yeah? They are someone that I need to build a friendship with, a relationship with, because they can become an ally of mine in actually getting the company to have better monitoring and observability, right? I don't forget them. There are other ways to spot some of these people, right? They're often the people that are always turning up to every incident, that their colleagues look to help them debug or troubleshoot, their code and infrastructure and stuff. These people are your friends. We need to speak to them. We need to make sure they know who we are. We need to, understand their problems. We need to help them, because ultimately we do need their help to help our organization and to make sure that we're providing that return on investment that ultimately is, why we get paid and things. And one of the most important ways that we need their help, right, is we don't ever want to, if we're saying we're rolling out a new technology, a new tool, or implementing tracing for the first time or anything else like that, we do not want to, in my experience at least, just push it out there and tell everyone, go do this, it's all ready, okay? You should start small, okay? These friends of yours can be your early adopters, okay? They're going to help you iron out the issues that they have, right? You're going to hold their hands
at the beginning, right? You're going to jump on incidents with them and help them use tracing for the first time. You're going to sit in on those post-incident, analysis sessions. You're going to give them a really curated experience, right? You're going to build out the good use cases for the tools that you're doing, right? And you're generally going to remove friction in adoption, right? Regularly meet these people, bring them all together as well, right? Because I can guarantee that you will not have thought of everything. And the feedback that they're going to give you is invaluable. And they're engaged, right? These are people that care about it too. And the fact is that if they're struggling with something, if they don't like something, then you can guarantee that other people will feel that too. And one of the key things here is it's all about trust. Trust is a really important commodity, right? And it takes a long time to gain it, but it's very, very easily lost. These people that are engaged, you do have a bit more leeway with them. You can work with them to do this stuff, to end up with a good experience, because it probably won't be right at the beginning. But if you just send this stuff out and other people who are not so engaged are kind of finding out these issues, you know what? They're going to take one look, say, no, it's no good, and walk away. They've lost trust, and it's really, really hard to gain it back once you've lost it. Building a happy path, right? So it's impossible to account for every possibility. And as I said before, you can't mandate stuff, right? You can't provide one standard that everyone must follow and push it out there. That doesn't work. But some level of standardization is a good thing. So thinking about kind of common technologies, deployment methods, and everything, build around these, work with your early adopters to build a great experience, right? Make it easy for people to do the right thing. Lowering the barrier of entry, right, as some might call it. Things like access are really easy gotchas. So the amount of times that I've been speaking to people and said, oh, you can do this, and they say, oh, I don't have access to that tool. But we've given the entire company access. So I will sit down with them there and then, right? And work with them to log them on so that they know how to. That's a really easy thing to overcome. And if you're worried about kind of privileges and stuff, give everyone read-only access. So at least they can log on, they can look at the data. As we had a talk, as we were building out our tools in my last team, we kind of generally had a rule, a kind of motto that if you did it 10 times, then you should have automated it, right? So when we're thinking about onboarding teams and everything else like that, if it looked like we were going to do it 10 times, then you automate it. You put it into the happy path. And I like to think about the 80-20 rule here, right? 80% of the teams, the people that that are using our services, should be able to use them in a completely self-sufficient way, right? And by doing that, by achieving that goal, by reaching that position, we can actually spend the time that we have with the 20%, the people who have the niche problems, the people who genuinely need our help, who have interesting stuff to do that doesn't fit in our happy path. And the other thing about this kind of happy path is it changes, right? It's not a static thing. You can't build this one pipeline, forget about it, and push everyone onto it. Because, technologies change. What we're using now is different to 5 years ago, and everything else like that, right? And then there are, patches and vulnerability updates and all that other stuff, right? You do have to keep investing in this happy path. But it's worth it, right? Part of making things self-service is documentation, right? And I went to the last EU version of Monitorama, I think in 2018, maybe, in Amsterdam. And I was at one of the after conference things, having a drink and a joke with someone. We were talking about the quality of documentation amongst most tools. And we kind of agreed that mostly it's crap. But then I started thinking about the documentation that my team provided and I provided for all of our internal customers, because again, they're our customers, right? And I kind of thought about it and realized actually our documentation wasn't that great either. So I joked with that person that we should have documentation week. And I kind of went back to my team and everything, and we joked about kind of having documentation week and haha, very funny, Ivan, and everything else like that. Until one Monday I came in after having a few experiences of things that probably we should have documented and said, right, people, it's documentation week. And they said, haha, very funny, Ivan. And I said, no, seriously, it's actually documentation week. And I'm not going to lie, they were not overly enthusiastic about it. And looking back, I do kind of feel that I think I'd been given some really horrible bureaucratic tasks that you often get in large enterprises, and this was kind of my retribution and on my team. But you know, that's yeah. Anyway, right. The point is that documentation is stupidly important, right? How to get started, how to do common operations and things, and answers to most common questions. When we talk about trust, right? If you can show that you've invested time, that your documentation is great, that you've thought of these things, that you're trying to help these people, this is one way that you can actually gain trust amongst your customers. Yeah, train everyone. So we invested in my last team a lot of time in training. A lot of time in training, right? We had 101 sessions every month for all of our tools, kind of 4 or 5 tools or so, right? And we advertised these everywhere to engineers, to their managers, to whoever would listen, right? And it was kind of, for each tool, it was a 2-hour session that covered what each tool was, why you needed it, blah, 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 right? And we were starting to move on to the 201 sessions when I left, right? The point here is not to make everyone an expert. You are not going to make everyone an expert in 2 hours, right? It's to make them familiar, to make them curious, right? Learning new things is hard, and it can be scary. And the fact is that, you know, in our domain, traces are really complicated to read, to understand. If I write a PromQL query and it comes out what looks like right the first time, I'm more suspicious than I am happy, right? And I work in this domain. What we do is hard, right? And when you're trying to do this, right, what happens is that this can lead to people not bothering at all, right? If they don't understand it, if they're not given help, they get frustrated and they revert back to what they've always done before because they know how to do that, even if it's provably worse, right? Quick example, kind of log aggregation, getting a log tool that, you know, we can ship all these logs to. We rolled it out, but lots of people were still logging onto the boxes themselves because they knew how to do that. They were scared of that tool, right? That's human, right? So we have to work with these people, right? Some people are scared of change. Change can be scary, so we need to help these people, right? Take their first baby steps. Ease them in. Is it a lot of effort? Yeah. Again, it's a massive amount of time. You know, creating the training, right? Actually providing the training sessions, advertising these all, and everything else like that. It's a huge amount of effort. But is it worth it? Absolutely. Provide a safe space for questions, right? And as I said, learning new things can be scary. And people will have a lot of questions. Some of these will be really, really good questions. Some of these will be not so good questions. Some of them will be the same question over and over and over and over and over, right? Your chat tool of choice, Slack, for my last team, is a really important place to drive everyone to. One of the most important messages that we would give on our training session is, this is our Slack channel. Use it. Ask us questions. We will answer you, right? And, you know, I'm sure I don't have to say this to you all, but, you know, treat everyone with respect, right? Answer their questions. Answer them in a timely fashion, right? And then with each question that you answer, ask yourself, could this go into our documentation? Could we actually add this to our happy path and automate it away? When we became known as a helpful team, right, people who maybe otherwise would have given up started asking us questions, right? And then actually, when we answered their questions and stuff, then they would tell their colleagues, hey, this team are pretty helpful. They will answer your questions, right? And that's what you want. When I left the monitoring team of all of the Slack channels across the entire engineering things, we had more engineers in our channel. We had much more active conversation. We had engineers from one team answering questions from engineers of another team. Nothing to do with us. I'm immensely proud of that, right? it took a lot of time and effort and a lot of treating these people with respect and a lot of, you know, as I said, answering questions, no matter how silly, over and over. But we got there, and it was so powerful. One point to mention, right? If you do get asked questions that are in your documentation, point people to the documentation. Don't answer it there. You want these people to become self-sufficient, to help them build up that behavior. The other thing to be clear about is be honest. If stuff is failing, or if they've come across something that's not so good, admit it, point it out, say, yeah, that's not so good, right? This is your main point of interaction with people, right? And, you know, you can't fake, you know, authenticity. It's also a really good place to kind of advertise your training, tell people your you know, all the improvements that you've done. And also, if you are doing documentation week, then, you know, you can let people know that you're a bit busy and you might be a little bit slower because you're all having great fun writing documentation. Never forget, these are your customers, right? And if I can give you one takeaway from this, it's these are your customers, right? So you need them, kind of more than they need you. So please bear that in mind. So that's kind of it. Like, one last thing to do, right? So this is an open source project. It's kind of a micro framework that does auto instrumentation, and it's something that I've been involved in, and there's at least one other person here who's been involved in it. And actually, this helps with quite a few of the problems that I've been talking about, kind of developer-first observability and helping them understand the value of it. It's super cool. So yeah, please do have a look at this if you are coming across some of the problems that I spoke about today. And with that, thank you.
All right. Thank you so much, Ivan. That was great. We got a few minutes for some questions, so do we have any questions from the audience? Hey, you're just straight up food coma going down. Oh, here we go.
I'm curious how you, in listing all the different ways you're trying to do something and people object, one of the ones I've run into a few times is where the tool they have actually is legitimately good enough for them, but there's a business reason, like coming from above, where we're like, when you don't really, you can't make a compelling argument that it's better, it's good enough already, right?
Yeah, how do you convince that you need the better thing?
Yeah, it's a really hard conversation, and I've been on both sides of it, being the person to kind of say, sorry, we're taking that away from you, and being in the conversation to say, you know, like, actually, you know, I'm using this, why are you taking this away from me? And again, I don't have any great answers, right? Because, you know, like, people do, you know, you have to understand again, like, these are people, and they do build up affinity for these things, and that change is going to be scary. So the best thing I can say is, you know, be kind, be caring, right? Appreciate them and understand the fact, and, you know, kind of essentially say sorry. You know, I don't have any good, you know, better answers than that, I'm afraid.
Any other questions? All right. Great, let's give another big round of applause to Ivan. All right, we've got our two last sponsors. And then we're going to actually take a shortened break. The break would normally start at about 3:10. I think we're going to start about the same time, but then we're going to reconvene at 3:30. So we're just going to cut a few minutes off of that, kind of keep things moving along, and you know, close things out. So, alrighty, and we'll flip over the thing. Natalie's up there. There we go. All right, let's give it up for our first sponsor here, ObserveIQ.
I'm Ryan Goins, a product manager at ObserveIQ, and today I want to talk to you about reducing the cost of your observability. So, as we all know, the amount of telemetry data we're collecting is growing at an exponential rate, but unfortunately, our budgets are not. And so, to solve this, we built BindPlane OP, which is an open source observability pipeline, and it's So I would love to give you a quick demo, and I've got a video to avoid kind of network issues. But here we are in BindPlane, and this is a list of all of the agents being managed by the BindPlane server. So these are open telemetry collectors. Specifically, they're our distribution of the collector. For those of you that really know OTel, we're using the op-amp protocol. It's the agent management protocol to facilitate this. And we've got information about their status, the version of the collector they're running, the config that's deployed to the collector, and even the amount of data actually passing through that agent. And so if we zoom out, we've got this really nice view of all of your pipelines. So on the left, you're seeing the pipelines that are configured, the number of agents that configuration is deployed to, and where that data is flowing. We're also showing you the amount of data coming out of those agents at any interval, daily, hourly, and how much data is going into your destinations. And so you can get ahead of, kind of surprise bills. You can really start to see how much data am I sending where, and then BindPlane's going to let you make some improvements. So we're going to jump into some of these configurations. I want to give you a few examples. In this case, we're collecting metrics and logs from an Nginx web server. It's pretty chatty. You got a lot of data passing through the pipeline. And in the middle, we've got some processor nodes. And that's where we can insert processors to transform the data. Again, enriching it, reducing it, before we ship it off to Google in this case. And you'll see we've got quite a bit of reduction happening. So as we jump into one of these processors, on the left, we're giving you a snapshot of the log stream at that exact point in the pipeline. So you can start to inspect the data and think about how you want to transform it. In this case, I actually don't want a lot of these logs. I want to convert them into a metric and just count how many status codes I'm getting. And so we're using a count telemetry processor to convert those logs into metrics, emit the metric, and then that filter processor to drop most of the logs. You could reroute them. In this case, we're dropping them. You'll notice some attributes like this where there's just a hyphen for the value. Not super useful. Sometimes you'll see values that are just totally empty. And so we can actually just delete those attributes and save quite a bit of storage. So this delete empty values processor is doing exactly that. By default, it would just look for anything empty. We're specifying a string of a hyphen here, so it looks for that. And it will just delete those attributes from all logs passing through this pipeline. And that can be 15 to 20% reduction depending on the source. Now, a lot of you have maybe a Splunk environment, and so you've got your universal forwarders, and you're saying, I don't want to re-instrument with OTel yet. I would love to do that, but maybe not now. And so this configuration right here, we're actually pointing these universal forwarders at a fleet of OTel collectors managed by BindPlane. We're sending that data via TCP. And now we've got the visibility of that pipeline. The data's in the open telemetry format. We can do the transformations that I just showed you in that last configuration. And we've got the flexibility to reroute that data to other destinations. So here I'm splitting the stream, I'm sending to Google. A lot of times that's, hey, I want to just send stuff off to an S3 bucket and just get my critical data into Splunk. That's it. Those are a few examples of how you can use BindPlane to transform and reduce your telemetry. Would love to chat with you more about it. So find us up, by the sponsor booths or scan that QR code. Thank you so much.
All right, thank you, Observe IQ. And our last sponsor of the entire conference, but not least, we saved the best for last and all of those ridiculous things we say, is Armory.io. Let's give a big round of applause for Armory.io.
Okay, hi everyone. I'm Todd. I am from Armory, as he just mentioned. And so at Armory, we're a continuous delivery platform, and we have one goal, and that's to make sure that you can have enough confidence in your deployments that with every time your developers commit
you're able to deploy to production, and you won't be afraid to commit at the end of that. So one of the things that we do and why we're at Monitorama is we believe that the easiest way to be able to fix a bad deployment is to be able to fix it in real time, and in order to do that, you need to be tapped into your monitoring. You can have the best monitoring in the world, but you aren't going to be able to do much with it if you don't have the tools to easily act on that data. So with Armory's continuous deployment as a service product, we give you things like automated canary analysis, declarative configurations of your pipelines, multi-environment deployments, constraints for safety, a lot of other features, but I figured the best thing I can do is just show you how it works. So we'll do a quick demo with that. So we have a very simple system with a declarative configuration file. All we need to know is what you need us to deploy and where it needs to go, and that's really it. From there, you can give us different levels of configuration, and then you just send us a simple command, and gotta love linting. Oh, God. Give me live demos. What happened? I had one in progress. Let's try this one more time. There we go. Let me go ahead and we'll open up our UI. So when I sent that off, what it's doing now is it's configuring a multi-deployment or multi-environment deployment that's going to go from your dev environment all the way through to production. And as you can see, we start in dev, and we have different constraints that let you order the way things go. So in this case, staging depends on dev, prod depends on both staging and infosec. And because dev doesn't impact our customers at all, it's low risk, we just roll 100% out there, and I can go out and I can click here. It'll show me the status of it. It even gives me a nice little link I can click to an internal link that we set up for you if you configure that, so that I can open up my little app, and it'll give you some nice potato facts. And you can even see the split of where your traffic's going. With staging and infosec, it's the same thing. We roll straight to 100% because it's not going to impact our customers if something does go wrong. And now that it's done, we can actually reach back out to your CI, and we can trigger your integration tests or your security scans, anything you need like that. So right now you can see it says I've got a webhook running. If I was to go back to GitHub Actions, it probably just finished 14 seconds ago. So that should now be done. And now we're getting to the point of going to production. Production's high risk. We don't want to impact our customers. We don't want to go out at a bad time. So, and my pre-constraints have failed. Yay. And so in this case, we have checks to make sure that we can't go to production unless certain pre-constraints are met. And so in this case, it was awaiting a manual approval that I never gave. To be fair, it was supposed to let me give it. I don't know exactly what happened there. Gotta love live demos. It did ping me to tell me here in Slack that I needed to act, but for some reason it didn't let me do that. So I apologize for that. But what I can say is, when these happen, we have different strategies. So we offer you the ability to do blue-green deployments and canary deployments and progressive deployments and rolling deployments, basically all of the major deployment strategies. And with canary deployments, what we offer is this is a feature called automated canary analysis. When that happens, what we do is we will actually talk to your metrics provider. That could be something like Prometheus, it could be something like New Relic, and we will go out and we will query them, and we'll look at your metrics in real time to determine, is it safe for this to continue? And if the answer is no, we'll either automatically roll back, or we'll give you an option to say, is this a real thing? We can move forward. The way I like to put it is, here at Armory, we're not afraid to commit. We'll move forward sometimes. If you saw our shirts, but yeah, so that's where the metrics come in. We want to make sure that you have access to those metrics during your deployments in real time, so that you can do that. So hopefully you guys will check us out, and you stop by our booth. We do have a free tier for any of you who want to check it out. You can go to this nice handy dandy little QR code to check out our product information and sign up for a free account and give us a try. So thank you very much for having us, and we were happy to sponsor the conference.
All right, thank you, Armory. All right, and our last speaker is going to be setting up here before we head to our break. Sponsors are pretty much all cleaned up out there, but that's kind of why we'll do a shorter break after this.
But also shout out to doing the live demo, especially on this Wi-Fi. I know the Wi-Fi yesterday was a little dodgy, and hopefully today was a little bit better. I think it's actually kind of funny, the level of visibility we have into the conference Wi-Fi for an observability conference is shocking. There's none. It's like Jason has to call a person, gets transferred to like 10 different people, to then he finally gets to the point where someone, I don't know, realizes that everyone's on like the one router right above you. So such is life. Alrighty. With that being said, I think we're ready for our next speaker.
I'm working on it.
And it's going to happen.
That's right. It has already happened. Look at that. Like, I didn't even have to, wow.
It's just magic. All right, let's give a big round of applause for Christian. Wait, hold on. Don't applaud.
All right. Can you guys hear me? Okay.
So you'll have to, it's weird.
Okay, what happened? Like, oh my God. Yeah, you know, like I agree with you. I tried a lot.
Thank you to the Google engineer who did DM me. I'm going to send you a loom of my feels. If you could forward it to the appropriate parties, I would appreciate it.
That is just really awkward.
Yeah, that is weird.
I'm just probably going to do this again. Here, hang on.
Try that.
Yeah. Just.
Let's unplug it and plug it back in.
Have you tried turning it off and on again? Yeah, right, okay. Who didn't get that?
What operating system is this?
It is this thing called Linux. Right? Yeah.
So the thing that I'm actually curious about is I wonder if it's a resolution thing on the display.
Yeah, it could be, but I'm going to press this magic button.
Yeah, there we go. All right, now let's give a big round of applause for Christian.
Thank you, guys. So, okay, cool. So the first thing I have to tell you, it's really funny. Like, this is the first time in, I think, a decade that I get to use this clicker, because I haven't been on a stage this large in ages. And over the course of the pandemic, it turned icky. It's like the whole plastic is sticky, and like, this is amazing. So like, I'm just gonna, keep going. So hello, everyone. Thank you for attending my talk. Thank you for sticking around. My name is Christian. I'm gonna present to you an open source project that I've been working on and with for a long time. A couple things about me. So I am currently the tech lead for this project, which means that I get to influence the technical direction for this project a little bit more than I did in the past. I am not at home in the observability world. I have learned a lot about how you guys think in the last 2 days, but I am very at home in the network monitoring world and in the network security world. I am a recovering academic, so for about a decade, we used to write papers sort of in the network architecture, network security, network monitoring space out of a lab in Berkeley, where we also worked on Zeek a lot. So a lot of the research that we did over those years was basically enabled by that system. And these days, I work at Corelight. We're an open core company. We're basically commercializing Zeek and related open source technologies. And I feel very gifted in that I get to work with a team there, my team that is fully dedicated to basically advancing Zeek in that company. So that's great. So I'm just going to ask, like, how many people here know Zeek? There are some arms. Okay, this is awesome. But other than that, I have come to the right place. So good. So you guys are pretty technical. So I'm going to spend sort of most of the talk on a technical dive into what the system does, and then I have a little bit about use cases for it, and a little bit about the project itself, and that should sort of come to about half an hour. So it all starts with DPI. So DPI, Deep Packet Inspection, is something that I'm sure many of you have heard of, but I'll just sort of cover it anyway. And it means technology where you basically grab every single packet that goes by on the wire, and you basically parse as deeply as you can into it and sort of build up state around the connections that you see, what is going on in these, and so forth. And so I'm going to be building up this architecture diagram sort of from the bottom, and the first thing you have to figure out in Zeek, hope you guys can read that, is like with many network monitors, if you want to process traffic live as it sort of like flies by, or if you want to process traffic that has been canned and basically like recorded in a PCAP. I'm sure almost all of you know a PCAP. This is basically literally taking like every packet that flew by and dumping it into a file. So Zeek can operate in one of those two modes. And everything in there is pretty pluggable. So if you have, a particular networking card or use particular hardware for this, then there's a good chance that we can support whatever you have. And we ship by default with about 70 protocol parsers that sit on top of this, that basically do this DPI parsing that I was just describing. And the way you can picture this is that basically in every analyzer, there is parsing happening that is sort of appropriate for that protocol. And the next thing that we are is a distributed event-based system. And what I mean by that, I think here too, you guys all know what an event-based system is. It's basically one where, you know, the code flow is not predefined. It basically sort of happens driven by events that come into the system. And of course, you know, network traffic is a really good example of that. And so what happens here is that whoever writes an analyzer for a given protocol basically defines what are good events, natural events sort of in the lifetime of that protocol. Those don't have to have usually don't have a security context. We don't make assumptions about what is benign or malicious. This is just about what is happening. So for example, in TCP, that could be when a handshake gets established, or for DNS, it could be a transaction. For DHCP, it could be, you know, a lease that gets dished out, like stuff like that. And whenever such an event happens, we basically sort of shove it into an event engine that has, you know, a queue, and that you get to sort of, you know, just have sit there for a little bit. And so here are a couple of examples of what these events look like. So this is looking a little bit like a programming language, which is sort of foreshadowing where I'm about to go with this. So this is a really common event in Zeek, which means that, you know, a connection has been established. This is basically when a TCP handshake is complete. We also use that to describe UDP flows, for example, so connection isn't sort of super technically correct, but it's a detail. But what matters here is that this thing has a name, and it has a list of typed arguments. Here's just one. It's a connection, and a connection is sort of a record. It's sort of an object in Zeek that basically collects information about the endpoints and so forth. So this is a really simple one, but a very common one. This is a more complex one that is out of the TLS analyzer. We call it SSL for sort of historical reasons. And you can see that it has a lot more arguments that are typed and sort of basically reflect what happens when you get a client hello in a TLS connection. And so these are two examples of, I think, about 500 total. So over the years, you know, a bunch of stuff has sort of built up. And these are all things that you can hook into if you put together an analysis that cares about these events. And I was sort of like just saying that it looks a little bit like a programming language, and that is sort of yet another thing that is Zeek. It also ships with its own scripting language that is basically a domain-specific language for analyzing network traffic. So it has really nice features for you know, representing addresses, for keeping state, for dealing with connections, and so forth. It sits on top of the event engine in a script interpreter that is very sort of configurable. It's largely procedural. It has a notion of event handlers that I'm about to show you, and is otherwise looking sort of, you know, strongly typed. Not unlike what you might know from, you know, C or Perl or Python or what have you. Let me show you an example. So this is a small Zeek script. It is fully functional. You could dump that in a file and run it. I'm about to show you what that looks like. And the details don't matter too much here, but it's just sort of to give you an example and to give you some intuition of how these things work. So in the first line, you have a global. It is a set of addresses. Then you have an event handler for this connection established event that I was just showing you. And in it, you define what you do with this event. And here you just see that in this particular language, you add the originator of that connection. This is sort of this cryptic looking part there in the square brackets. Gets added to that set. And in another event handler that sits below called Zeek done, where the whole thing basically shuts down, we just have a print statement and then iterate over that set and dump it all out. So it's really you know, pretty straightforward. And so if you run that, it would look like this. So you can run it on a PCAP, like I described earlier, and assume that I just took that script and dumped it into, you know, awesome.zeek and run that, and then, you know, you get something like that. For the test PCAP that I used, this was the actual output. So I already asked how many people know Zeek, so I don't really need to ask how many people know the Zeek scripting language, and how many people know JavaScript. I have good news for you. So we're about to come out with Zeek 6, which is our latest major release. It probably comes out actually next week. And this is the first time in the history of the project that we're sort of branching out from the original scripting language for the exact reason that we could just demonstrate that basically like it's yet another scripting language that people have to master. And there is just a lot more awareness and familiarity with JavaScript. And it is, I think, quite fascinating to me that we were able to add all of that support within Zeek without actually changing Zeek itself. This is all done within a plugin structure that exists in the system. And the exact same script that you just saw would look like this in JavaScript. So it is very much the same. I'm not going to go through it line by line, but you have all of the equivalents of what I just showed you in Zeek script here in JavaScript. So you have the set, you have event handlers, you add state. When you're done, you dump the whole thing out. All that changes is that instead of .zeek, you can now say .js, and you run it, and it looks exactly the same. We think this is pretty exciting because it should make it much, much, much simpler. This is based on Node, by the way. I didn't say that, but if you saw the .on and so forth, you probably could figure. So it's pretty exciting what that should enable just because of the vastness of that infrastructure and that ecosystem and all the stuff that's there. All right, the next thing that Zeek is a log writer. So I told you that the script layer is very configurable, and so there's this question about like, well, what does Zeek actually ship with by default? Like, what does the script layer actually do by default? And by default, we basically give you really good logs about what is in your network traffic. And so the way this works is that we have sort of this one standard log that we call the conlog that is sort of like NetFlow on steroids. So if you know NetFlow, you know it as sort of a per flow connection summarizer, and that is basically what this is. So it tells you the endpoints of a flow, it tells you which endpoints were local to your network, it tells you how many bytes, packets, and so forth were transferred, and it tells you what protocols and services we found in a given connection. And so that's sort of the hub of our logs, and then there's a whole bunch more. You get about 60 of those, and you can think of those as sort of a combination of, first of all, sort of protocol-specific logging, and then also sort of related concepts that you find useful. So for example, there's a files.log for all files that Zeek was able to recognize in the protocols that it can parse. There are logs about sort of strange things that are happening in the network traffic that don't look quite right, and so forth. And to come back to the architecture for this a little bit, so on top of the script interpreter, if you will, sort of going back into the rest of the architecture, there is this logging engine that is, again, very pluggable. By default, we log to files. Most people these days will want to use JSON. There's also a historic sort of tab-separated format that you can use, but there are plugins for lots of other exporters. So a lot of people, we're working with Pump into Kafka. For a lot of other people, it's Splunk. We really like Humio, now Logscale. So it depends. I've noticed that in different fields, there are sort of different preferences for what is a good log ingester, but I would actually stress that there are certain benefits in actually sticking with old school text files. We know lots of sites that have like years-long archives of text files because they can always go back and process those files really nicely no matter what is sort of the data ingestion technology du jour, right? So it's incredibly powerful. An aspect here that I wanted to flag is that, you know, I didn't show you how the logs actually come out. So as part of this invocation that ran here, we didn't just get this output that we programmed into the script layer. This other stuff ran as well. So I got this bunch of logs in my directory where I was running this, sort of highlighted in bold there in the bottom right. And this is all basically logs for the stuff that was in that little PCAP that I ran there. And if I go in and, for example, like look at the conlog example, then I can't quite tell if you could see that earlier in the example of this table that was describing the conlog. But in JSON, you would see that this is basically the data that are here for this given connection. It matters that the second thing up there is this string that looks sort of cryptic. But for example, if you look for this string in the other types of logs, then that gives you a really nice sort of, you know, anchor point to pivot from one log to another. So you can string together all of the things that related to the same connection, for example. So it's quite powerful. And a final aspect to flag is that the whole thing is designed with a pretty strong separation of policy versus mechanism. So all the parts that are saying mechanism here basically will always do the same thing. It's really just in the script layer that you define what you want the system to do. Like I said, by default, it gives you a good log writer. You can build other things with that too. Like some people build detections, other people build sort of anomaly detection models and so forth. You can go pretty wild. And this whole thing that I sort of painted here is one Zeek process. So if you just run Zeek like I just did earlier on that PCAP, then this is all the stuff that kicks in, so to speak. And if you remember that earlier, I said Zeek is a distributed event-based system, then you might go, where's the distribution, right? This is just one process. Nothing is distributed. There was one event queue and you were done. And that is because, especially if you monitor live traffic, you do not normally just run this one process. You run a cluster. And so the way that looks is that every blue box here is basically one Zeek process. You run a bunch of those. They basically get different roles. So at the bottom here, we have what we would call workers. Then there's this thing that we call proxies, which are basically sort of relay nodes. There's usually one manager on top of this and one logger, although you can have multiple if you need that for scalability reasons. And the key part is at the bottom, you have a network tap or a network card that understands sort of how to divide traffic up into queues. And then each of those workers sort of sits on one of those queues and does traffic analysis. And then we use PubSub, event-based PubSub, for Zeek events to basically communicate the rest of that stuff across this cluster, so that the analysis happens as needed. For example, sometimes the proxies and the manager will want to have some sort of like centralized state, and when some script in one of the nodes in that cluster decides it is time to log an entry to a file, then it'll send an event over, or more specifically a message, it's not all events, to the logger, and that thing puts it out. And so that's then a Zeek cluster. And for most people these days, you can run this on one machine. You can have machines with an incredible number of cores these days. But this architecture sort of dates back to a time where if you wanted to run something on multiple cores, it basically meant you had to run it on multiple machines. And so in the larger sites that we're working with, those guys tend to actually run really a cluster of machines because that's the only way they can handle the load, and then you need a load balancer, a device that basically takes your network traffic and divides it up and sends it to that set of machines. Okay, so that was Zeek. So what is Zeek? So Zeek is a mature, extensible, distributed, event-based, scriptable network data logger. That's everything I could think of sort of and put it in there, which is why I love to work on this, because it's really kind of cool to have one thing to work on that is all of these things, like a network monitor, a distributed system, a programming language, so you can sort of iterate through things, but it's also clearly a mouthful. So a couple more analogies. Zeek is a lot like longitudinal TCP dump or Wireshark or T-Shark or whichever of the packet recording tools that you're familiar with, except it's more focused on the flow level. So if you use Wireshark, then maybe you know that you sort of like usually like open up a small PCAP and you like dig into the headers of particular protocols. Zeek is sort of the same, but for all of the traffic and that flow level. You don't really care about packet level activity so much. You sort of abstract to the stuff above it. Another analogy that I really like is Zeek is a lot like eBPF tracing. So if you make an analogy between all of the events that it gives you and eBPF trace points, then it's actually very similar. You need to figure out sort of which of the ones matter to you, what code to run when you hit that, except I would argue that it is much easier to do in Zeek than, especially given the JavaScript ability that I just showed you, than eBPF, but the analogies I think are pretty strong. And more than anything, this is Zeek. So if you want one thing in your head sort of that you will remember, then it's a network flight recorder, because for most of the sites where we know Zeek is running, that is really the model or the reason why they use it. So you capture a lot, but not all of the data in your network, and when something goes wrong, you go in there and you use that data to figure out what went wrong. Okay, so if you want this one image, that's sort of it. Zeek is a lot more. I'm not going to go into tons of details about this, but there's this whole ecosystem of things around it that we've built out over the years. And just very briefly, there's a package manager for that script layer that I told you about. So if you write something that you think is useful, you can basically write a little package. We can add that to our standard repo of packages, and then other people can use that on the command line with a package manager that is very much like DNF or apt or whatever you're used to. This can also include plugins, so native code. So you can really write these packages to fundamentally extend Zeek, so to add a new, NIC driver, or to add a new output module, or to add a new detection, sort of what have you. That's really sort of where the open-endedness of the whole system sort of pays off. There is a thing called Spicy that you should know about if you ever write parsers for network protocols. I don't know how many of you guys do that, but this is basically another domain-specific language. This is one that basically can capture the syntax and the semantics of a network protocol sort of concisely, and that gets compiled to something that can run in other systems. In this case, it compiles to C++. And does that in a way that is basically designed for streaming data, because that's sort of what defines network traffic. You get sort of data coming in chunk by chunk, and you need to make sure that when you access, the umpteenth byte in a buffer, that you can actually do that safely and not blow out the buffer and so forth. And that's exactly what that gives you. And it's beautiful because it is not actually built for Zeek. We're using it in Zeek, but we're, for example, also talking to the Wireshark folks because they might start using it for some of their dissectors, as they call them. There's Broker, which is our message broker, which is the thing that enables the cluster communication that I showed you earlier. And I wouldn't otherwise call this out here because it's sort of an internal detail, but there are language bindings just for that, for example, in Python and Go. So you can use our bindings to basically communicate Zeek events from other systems, like with a running Zeek cluster, which can be really useful if you have, like, in Python, some ML model trained, for example, or something that, where this particular ecosystem is really good, but in Zeek script itself, it would be nuts to build that from scratch. So you have ways to extend it that way. At the bottom there, I'm mentioning some cluster managers, because if you run a cluster like I showed you earlier, then you want some infrastructure that makes that easier. And down on the left here, I'm mentioning Zeek Agent, which is basically our first sort of foray into expanding beyond the network. So the idea there is that you can run agents on Linux, Mac, and Windows systems that basically hook into the host level activity and still generate Zeek events. So you can basically then link, what user created a network flow and so forth. But this is kind of new for us. We're sort of like, exploring the first sort of deployments of this. But it's quite exciting. So I just wanted to convey that there's a little bit more going on here than just sort of Zeek itself. All of this stuff is BSD 3 licensed. So it's very liberal. You can basically take this and almost do whatever you want with it, including commercial use. I think this is sort of our heritage out of Berkeley. We just sort of strongly feel that that is the right license for open source software. Okay, so that was the technical deep dive, and I did not look at the clock. I'm sure I will be reminded when I'm running close. So a couple words about use cases. So the main use that you probably already sort of gathered here is better network data. And if you think of like how people normally capture network data, then there are really sort of only 4 ways in which that is done. So the most traditional is PCAP. So like I said earlier, take every single packet on the network and dump it into a file, right? So you have perfect data fidelity because you're literally capturing everything that was on the network at crazy data volume because you're recording your network. So there are only very few organizations that can do this at any reasonable scale for any reasonable amount of time, and even then it's incredibly wasteful. And then you have sort of the absolute opposite, which is good alerts. So this immediately makes assumptions. So now you are assuming that you care about detections, you care about alerts where there is some built-in assumption that something bad has happened, for example, and you might get that sort of like represented very well in this like little nugget that is this alert, but you're missing all of the context around it, like what led up to that, right? And then more commonly there's crappy alerts, like basically the same thing, but at crazy volume, right? Like there was a great talk yesterday about alerts and what they smell like and so forth. And then I touched NetFlow, and that's basically sort of the closest thing there that's sort of, generally useful. And the beauty of Zeek is that it sort of like sits all over the place in there because you get to decide how you want that to be. And because you write code that defines how you collect the data, it also means that it isn't fixed. So for example, you can start collecting network logs that are pretty coarse, that are relatively abstract. And in security incidents, there's a common pattern where, once something starts happening, it remains pretty localized to that network because like some attacker sort of like pop one box and then sort of manages to start jumping around a little bit, especially with viruses that were spreading sort of autonomously. That was sort of a classical thing. So if you get sort of, for example, first indications that something might up, then in that corner of your network, you can start to look more closely because you can adapt. So the whole thing isn't as fixed as with any of these other models, which I think is very beautiful. And so what is that used for? And so like I said, I sort of come out of the security domain, and this tends to turn into acronym soup, but you'll hear things like, network traffic analysis, network security monitoring, network detection and response, digital forensics and incident response, threat hunting. And I think these are all true, and they're cool things, and you can read up on them, but especially for why we're here, it's sort of the stuff in the middle there that I think matters a lot more. And it's sort of this triad of observation, validation, and discovery. And I have a really nice anecdote from a colleague of mine. His name is Richard Baitlick, who, I don't know when it was, but at least a decade ago or so, was charged with basically securing the GE, General Electric network, right? And so this is, I think, far more than 10,000 endpoints, vast network. How do you start? And he did not start by, like putting firewalls in place or intrusion detection systems or enforcers or what have you. He basically took Zeek and deployed that all over the network for a year to just learn how that network actually works, because in most large networks, nobody has like the map, and then you know how this thing works. So you learn, and once you've learned, then you start thinking about enforcement and so forth. So I think this is a nice sort of concise way to think of like what you would actually do with the data. A couple words about the Zeek community. So it's kind of interesting. We have very sort of different sets of users. I sort of categorize them as security teams here. That makes sense, again, from the examples that I just gave you, but also network operators and then observability engineers. So basically they all sort of come to this, but with sort of slightly different intentions. And where it gets interesting is that all of those folks bring very different skills. So for example, network operators usually know their network like nobody else, but they tend to not think of themselves as developers. So if you give them the ability to script an analysis on top of 500 different types of events, they often go like, that's great, but I'm not going to do that. So this is where we're hoping that this package ecosystem can help and so forth. And this is sort of similarly true for these other groups here. And who's using Zeek? So this is sort of a classic, logo slide. These are all folks that we know are using Zeek because either they've told us at our own user conference, or because we've inferred that from job postings or just talking to them and so forth. And perfect. That's great. Thank you. And I want to give a shout out to Microsoft. I don't know in which talk that came up yesterday or between which talks yesterday. Like, look at what happened to Microsoft. This is incredible. So you might have heard of Microsoft Defender for Endpoints, their security solution for endpoints. And they figured that they wanted a way to also record and analyze network traffic that is passing or traveling to and from hosts where Defender is running. And they settled on Zeek because they realized this is basically already doing exactly what they need. So this is from one of their blogs. And not only did they make that decision, they also decided to basically open source that whole contribution. So we were able to work with them because none of us in the team is a particular Windows expert. And we were able to work with them to get that to run and build, and that got merged in the second half of last year and is currently in our most recent release, which is 5.2. And so people running Windows can actually at least, given this, like start to explore that system in that OS where otherwise we wouldn't have had a chance. So kudos to Microsoft. We all thought that was incredible, and that is a continuing relationship. They're doing more stuff now with it. Very exciting. Couple words still about the Zeek project. So I have alluded to the fact that we've been doing this for years, and I wanted to show you, excuse me, just how many. So in the Zeek source tree, there is a file called changes, which is basically an old school changelog. And if you go in there and you tail it and you go to the very end, then you get there. So like 1997. So I'm here talking to you about a project that has been out there for like 25 years. I think that's pretty cool. It's sort of gone through many changes, and it took a long time, I think, to gain traction outside of that small little academic bubble in which we were working. And this is a photo from the Usenix Security Symposium. I don't know to which extent you guys are familiar with this. This is hosted by an organization that is very much into open access. You can just go to their website, pull up papers. It's an incredible conference. There's crazy stuff in there every year. I highly recommend it. And they do these Test of Times awards. awards for things that basically have proven their worth. And the man you see there in the middle is my colleague and former boss, Vern Paxson, who started this thing in 1997 at Lawrence Berkeley Lab. And he, you know, whatever that was, 25 years later, basically got awarded for this thing that is now basically being commercialized. Like it was rather ahead of the time. And if you look closely, it says there that it was called Bro. And so we renamed it about 5 years ago, because back then this was sort of an innocent pun on like Big Brother is watching your network, right? And I remember, I think it was about 6 years ago, the head of marketing at the time at Corelight was in a call, and I sort of walked by him as he was sitting on the couch, and he's sort of like, yeah, so I don't know if you've heard, but we're commercializing this network monitor that's called Bro, and it's like, yeah, no, it really is called that, and like, yeah, so, and it basically derailed there, and it basically got to a point where like VC funding would not have happened, for example, if we're talking about a thing called Bro, and like, very justifiable, right? So, but if you're ever wondering, or you see old material, it used to be called Bro, it's now called Zeek. Zeek is a pun, it's not a pun, it's a reference to the user account under which Bro used to run at Lawrence Berkeley Lab in the very early years. It's a Far Side reference for a dog, it's sort of a crazy story, but now it's called Zeek. and that's that story, so now you know. There's a pretty elaborate project structure. We have a leadership team. If you're involved for a while, you can get elected into it, and then there are sort of subgroups and so forth that are structured from it. You can read up on all of this on our wiki. Pretty cool. This is the core team. We're sort of 15, 16 people right now. About 7 of them do actual development, so we are small but mighty. It means that basically we're really busy, and the only way we can do this is because we take our liberty in when we release and so forth. This would otherwise probably not really come together. If I got you excited with this at least a little bit, you have at least 3 ways to get it. You can just run it straight out of Docker images that we publish. So do a Docker, you know, run it Zeek or some such. You can pull down specific versions. We have binary packages for various distributions. We don't currently have distro native packages in any distributions. This is a bit of a bummer, so it can't be on like Debian and just sort of install it, mainly due to lack of cycles. If we find contributors who are willing to work on that, that is wonderful. On the Mac, we're on Homebrew. On the BSDs, we're in the ports collections. These are external contributions for which we're very grateful. Or you can build it from source, which is actually not very difficult. The link to the documentation is down at the bottom. You can just sort of grab it and take it from there. And that's it. Get involved. So I have sort of a typical slide here of things that I'm not going to read through. I'm just going to highlight 3 things. If you're interested in this at all, especially since I'm sort of talking to a slightly different community, come talk to us and tell us about your use cases. This is really critical. We want to build things for people that are actually, you know, that know what they want to use this for, so we built the right thing. That is not necessarily a given. We don't know everything about these adjacent communities. Like, I'm completely new to this observability world, as I just told you. So this is important. If you want to contribute something big, this is just like with any other project, please sync up early so we can coordinate with you so it succeeds. And this is probably less relevant with you guys, but we are always looking for people who are testing our release candidates in their own clusters, in their own networks, and so forth. Should you be interested in that, please come talk to us, no problem. And with that, I'm done. Here are a couple links. You can find our community links there for our Slack and discourse, the documentation, and so forth. So that was it. Thank you, guys.
Great, thank you, Christian. I will say I've obviously known of Bro for a really long time.
Right.
I didn't know it was actually short for like the Big Brother.
Yeah,
so,
it was sort of.
But also, thank goodness they rebranded it too, because I had many of those similar conversations of,
completely
wait, what is this tool? No, we're not using that. So, any questions? Any questions for the audience here? Yeah, we got one right here.
How well would Zeek run in a resource-constrained environment like a Raspberry Pi?
Yeah.
So how well would Zeek run in a Raspberry Pi or resource-constrained environment?
Yeah, thank you for repeating the question. That is a great question. It is also, I'm going to punt a little bit because it's very hard to answer. It depends too much on the actual traffic that thing is monitoring. So a good example is For example, DNS traffic tends to be a little more heavy because it's usually, at least if it's sort of traditional, many small packets. Small packets have more per packet overhead, tend to exercise the system harder. It totally depends. Something like a home network should be a no-brainer. It's also like no matter in what setting you run it, at some point this question will come up, like what can it sustain? And there's sort of a tuning phase that follows at this point. You can disable certain analyzers, protocols basically that you do not care about. There's often something like that. You can exclude parts of the network. Dicey, but sometimes reasonable. So it basically depends, and it is really hard to tell ahead of time, like even what the bottleneck is. It might be your logger, it might be like your workers, depending on how many you have, and so forth. So try it out and see where you end up, and then come talk to us. Like if you check our Slack, there are tons of performance questions in there, and we almost always figure something out. Yeah.
Awesome. Any other questions? One last thing. Yeah, we got some. Are there two different ones, or are you just really waving me down aggressively?
It's completely
Go for it. Do you support hardware timestamps?
Yes, because I think a lot of NICs give you hardware-based timestamps, right? Solarflare, I can't tell you right now. But for many of the packet sources, like our notion of this, that basically use the platform native drivers, the timing actually comes from the NIC. It's really only I think really old school PCAP or libpcap, packet capture that is like standard kernel power that where the timing is not actually out of the hardware that captures.
Can you support a specified field as the timestamp of the packet?
That is a great question. That would depend. If we're doing the parsing, yes, because it's up to us. If it's something that is not accessible to us because it's completely buried in the link layer or something, or the physical layer even, right, then no. But usually that is the case, yeah. Like that we can get to it, yeah. Yeah.
Last call, any other questions? There's also a speaker channel in the Slack, obviously. You can continue the conversation there. All right, another big round of applause for Christian.
Thank you, guys.
All righty. So we are going to move on to a break. We're actually going to shorten this break down to, I don't know, like 15 minutes. Basically, we're going to reconvene back here at 3:30 for our last speaker. Unfortunately, our last speaker, Alex, oh my God, I got my flashlight on like some boomer here, Jesus. So we've got our last speaker unfortunately hurt his back and just can't sustain being on stage and giving his talk. So unfortunately we're I would say, or fortunately for many of you who are exhausted like myself, we are going to end early. So at 3:30 we're going to come back. Dave's talk is going to be up. It's going to be amazing. Then we're going to close things out and do the raffle. So take a break. We'll be back here at 3:30. Thank you. talk of the day. After this talk, Jason's gonna close out just a short presentation at the end, and then we're gonna do the raffle. I don't think it's too late, but if you still have 2 tickets, right? If you did not give one in, drop a message in the Monitorama Slack so we can grab it if you do want to take part. The prizes are admittedly pretty awesome, and you're probably gonna be sad if you miss out on that. So, all right, with that being said, I'm super excited to introduce our next speaker. Let's give a big round of applause to Dave.
Hi there. I started to come out here and do Hamlet's soliloquy, to be or not to be, that is a question, but somebody told me it was the wrong stage for that. So anyway, I'm Dave McAllister. I work for a little company that you may have heard of called Nginx. We're one of the most widely used open source packages in the world. Something like 64% of all web traffic flow through Nginx on a daily basis. But this talk has almost nothing to do with Nginx. This talk came out of a series that I do on data science for observability. And the piece that becomes really important for that is that when we start looking at scale, rules may change. But in one of my talks, there's one section that I'll actually get to as part of this talk that people would scratch their head and say, so how does that work behind the scenes? And when we started looking at this, we found out really quickly that we do a lot of numbers, but very honestly, most of us have no clue as to what the manipulation is anymore. This group is probably a little different, but when I'm talking to basically the pure dyed-in-the-wool observability guys, they really don't understand that. But to start with, I'm going to start with a simple question. What's the difference between mean, median, and mode? And I'm watching around the room and seeing people go through this. And most of y'all probably got mean. Somewhere between 68% of you understand median. And somewhere around 35% of you probably can remember mode somewhere in the past. But if you got all 3 of those, by the way, let's add in the extra credit question. What's the 9th data kind number? It was just discovered, like end of last week. It was finally published for the first time. So if you actually know what the 9th data kind number is, great. Come up and do the talk for me instead. So, monitoring is a numbers game, very honestly. Standard red dashboard, rate, error, duration. Inside of that dashboard, there's a lot of information that's happening behind the scenes. I have aggregation going on one part of this. That aggregation is over a 10-second period. I also have strip charts that are showing me this data in real time. And I have percentages that are going on. I can also have alerts set up around this. Those alerts can be lots of different things for here. You can be looking at an average, you can be looking at historical anomaly, you can be looking at all those different pieces. Generally, and it has to be, they're time-stamped. So we know what order they came in here, and they're usually key value pairs. Timestamp, metric name, metric number. Metrics, I'll do these things. Data, to be useful, has to be aggregated. We can't sit and watch our data on scale flow through like you're doing a tail minus F on a log file. The data is too much now, so we need to be able to aggregate it. We need to be able to analyze it. We need help to be able to look and find out what's going on. No one is going to be doing a running 10-second average going across these models here. And then finally, it has to be visualized. Honestly, visualization is less of a characteristic here, but as we all know, dashboards sell executives, and executives pay the bills for the tools. So those are the pieces that are going on there. And it tends to answer some interesting questions. So we now understand what the alerting structure looks like, but how do you deal with outliers or spikes in your monitoring? Remember, spikes can go both ways, up and down here. How do you get a representative value between vastly different quantities? So when you're comparing things together, are you picking the right piece, the right statistics? How do you arrive at values that represent the rate of change? And then finally, the real question is, what's the alert really telling you? So keeping those things in mind, and we're going to go through some of those aspects. So my starting question, mean, median, and mode. Here's a data set. I think it's like 31 numbers put together here. The mean is a measure of central tendency that represents the average value on a set of data. And in this case, those numbers add up to 5.444. The median is the middle value of the ordered set. So put all the numbers in order, pick the one in the middle. If you got 2 in the middle, average them together. And the mode is the one that appears the most often. In this case, the mode is 1. So back to this mean thing. Our mean is 5.4 and change. Or is it? Is the mean 4.13 or is it 2.791? And the answer is yes. Because this was a trick question when I started off. The one you're all thinking of is something that's known as an arithmetic mean. And there can be lots of different means here. We can have arithmetic means, harmonic means, geometric means, trimmed means, weighted means, moving means, all given together. Each of these has a potential use as well as a potential drawback. And they give you different insights to your data as each piece goes forward. Almost all of these are implemented somewhere in your monitoring software, and the ones that I'm going to talk about that aren't, I'll give you the pointers to R, and most monitoring software just pulls in an R function without any words inside of here. But as you can see from that first number, they can give you really different results based on what you're looking at. It makes like and unlike comparisons a lot easier if you can understand which of these you use at which particular time. So the one everybody thought of, this is the most common, arithmetic. Add the things together, divide by the number. That's very central. It's the central point in a normal distribution. It is not the 50% mark unless your central point is 0 and your standard deviation is 1. So you can't say the mean is 50% up or 50% down. Interesting piece of information, but most of us automatically assume mean is 50%. Not there. It's very useful for comparing to previous conditions here, and it usually gets aggregated in monitoring into a little time series, either a moving time series, where I'm going to pull the last 10 seconds of data as it moves across, or in a batch process where I'm going to put 10 seconds in a batching process. In a time series, we usually need to constantly reevaluate, add the new data in, subtract the old data out as we're moving across. This gives us the best trend lines that we can look at. So here's a simple little load balancer example. I have a load balancer that's feeding into 3 systems, 33 requests per second, 5 requests per second, 1.6 requests per second. The arithmetic mean adds those together, divides by 3, and comes out with an arithmetic mean of 13.33 requests per second. Looks like a very solid, sound number. However, this has a tendency to weight the largest value heavier than any of the other values. So, when we look at this problem, we have geometrics, another central tendency inside of here. This one's a little more challenging. However, computers are now fast enough to deal with this. Back in the old days, you would have needed a Cray 2, 1991 Cray 2, or something to calculate the geometric mean of a 100-item object, because you multiply all the values together, and then you take the nth root. So the 100th root of 100 things multiplied together. Today, computers laugh at you when you do that. They give you the answers on instantly. Even Microsoft Excel will do that, blink of an eye for this. In DevOps, we find this used in the number of deploys per unit of time, how often we're deploying. This becomes an indication of those things here. Or the lead time to changing. How often are we changing things for this? Mean time to response, mean time to recovery, all become part of this. But in this case, we use throughput, because throughput is something that's got a unique concept when it comes to a geometric mean. Same load balancer example, same numbers over this, but my geometric mean is 6.525 requests per second. This number is actually the number you would get if you took those 3 systems, crushed them into one system, and ran that without a load balancer. That's actually the balance number that's showing up in a load balancer model. The geometric mean gives you that number. So keep this in mind that when you're looking at different pieces here, arithmetic means are easy and commonplace, but it may give you a false indication of what's actually going on in the system. So the third of these, what are called the traditional historical whatever, is harmonic. And harmonic means are used where we have different systems that we're trying to compare things across those things. The harmonic mean weights the lowest number heaviest. The arithmetic mean weights the biggest number the heaviest. And so when you look at these two things, this will give you the balance across looking at the lowest possible value. So this one, you take the reciprocals, you add the reciprocals together, and then you divide that into the number of units. So in DevOps, we find this as a performance over range. You'll find this used in things like latency, throughput, where the numbers come into play, and the numbers have different values that are not necessarily equivalent. And so here I'm using a computing example, fairly straightforward. My CPUs are running at percentages rates. My first one, I've got 30, 40, 20, 10. You read the numbers here. My harmonic mean, it says that that system is roughly 20% utilized. An arithmetic number for that, if I remember what that number is, of course I didn't write it down here, is substantially higher because it is going to weight the 40 higher. And I think if I remember correctly, it comes out at about 22. So not too much of a variance. But when you suddenly spike something, and in this case, node 4 spiked to 80, node 3 dropped to 10%, my harmonic mean jumped, even though I lowered the lowest value. And this is a problem with this. An outlier spike for harmonic mean may give you a false indication, false positive indication. So 3 simple little mean structures, arithmetic, geometric, harmonic. Why don't we ever use those other 2? They're incredibly powerful. Well, there's a single reason that we tend not to use them, and that's that anything that has a 0 value in it destroys them. So harmonic mean, I'm dividing by the value. 1 divided by 0 is not defined. In the geometric, I'm multiplying by the value. Any number times 0 is 0. And so therefore, we have to make sure that if we're using one of these, we're providing them real values. The real values are important going across each of these pieces. So the second part of this median, where we have the central value. Now, the interesting thing is, I told you that mean is only 50% under certain particular rules. The median is always the 50% mark. 50% is higher, 50% is lower. So if you're looking to do a 50% comparison, P50, P50%, the median is your mark. It's higher than that, it's over P50. It's lower than that, it's less than P50. And so here's a simple case. This is actually a trace of request data coming in again. Request data coming through here. The median at the endpoint here is 26, and the mean is 25.25. The first few values, by the way, are meaningless in statistics. Statistics is an aggregation. We do not have statistical meaningful relationships with a single number. And so when we look at this, you're going, it's pretty close, pretty cool. But I mentioned, for instance, historical anomalies. Say, for instance, you are looking at your sales on every Friday, and you're running Fridays back for 3 months. And all of a sudden, something happens, and you get a spike. And all of a sudden, that data is no longer in that lower end range, but I now have an outlier that's 250. My mean jumps like crazy. Alert time, boom, bing, bang, bing, bing. Alerts almost anything on this. However, that mean does not return to the standard value. So it will be a period of time before it calms back down to what you're looking at, which means that your alert, if you're set off that mean, that arithmetic mean, may not find things for several periods of time. The median, on the other hand, jumped from 26 to 26.5. And in these cases, what you'll find is that the median is a much more stable approach to looking at your baseline for an alerting structure, particularly in anything that's looking at historical anomalies or sudden change. The median will give you that data against the current data point more accurately over time once you've established what that is. Now, just to pull it back in to play a little bit here, harmonics can also be used. They are an indication of the median structure. And that median structure, again, if you can see what's going on, the harmonic is the bottom line, the median is the middle line, and the mean is that blue line at the top. Harmonic changed a little bit. Median changed a little bit for this data set. Mean jumped way up. And so you can, if possible, use that. It's a lot easier to calculate the median than it is to calculate a harmonic. So I strongly recommend that you take a look at what the median can do for you in your learning structures. So mode. Mode is most commonly recurring value in a set, usually as a histogram, and not very often used. Generally speaking, we find modes showing up when we do log analysis for this. You'll see it's showing up in security monitoring. Is somebody having a lot of failed attempts at login? Or you can look at a user behavior. What is the normal pathway that a user is going through? And we can start looking at those as inferentials. That structure is really useful when we're doing the secondary deep dives. The metrics will usually tell us that we have a problem occurring on. The mode will help us understand why the problem is occurring, especially if it is a reoccurring problem. And so the mode is most useful in this inferential space. So distributions for this, I'm not going to cover too many of these, but again, probably most common with the normal or Gaussian distribution. That's our famous bell-shaped curve here, but there's lots of other things in here. You probably made some use of what's called a beta distribution. A/B testing is a beta distribution. Two binomial objects, which one wins? And each of these pieces, again, can have different structures and different pieces. A little deviation. To talk about distributions, we have to talk about standard deviation. And this measures the variability, how much your data varies across this, and can help you identify trends and outliers. It is not percentage-based, unless you're doing this thing called a coefficient of variability, in which you make it into a percentage. But it can give you a percentage indication. In a normal curve, one standard deviation is roughly 68% of all the data under that curve. And you can read it, 95% is 2 standard deviations, 99.7 is 3 standard deviations. Why? This gets used a lot when we start looking at things like lead time. How long did it take us to respond to something? What's our standard deviation across that model? Or what's the recovery time? Or how many anomalies are we seeing? Each of these pieces gives us a different set of information. The standard deviation is near and dear, and it's an underlying for almost every distribution of some sort. But I want to cover a couple that you probably have never had a lot of time looking at. This one's called Weibull. And Weibull is time to failure analysis. So this is how you can figure out what the odds are that you're going to lose something over a period of time. Here I took a simple little hardware system. My old spinning rust disk has a 500-hour time to failure model for this, memory, so forth, down to the solid-state disk, which is actually the most stable piece here. Don't ask the math. I don't have enough time or slides to put it up. But R does it all for you. And so when you're dealing with this, you simply find 2 pieces. You find basically the shape and the scale parameter by handing it this data. And then from there, you can do the next call, which says, what is the probability of failure of given this shape and scale of data for a period of time? In this case, my things all go up to 2,500 hours. So I said, what's the probability of the system failing at 3,000 hours? And it turns out it's roughly a 30% chance that something in the system will fail inside of 3,000 hours. This gives you an indication of where you may be approaching end of life in a distribution curve based on what your risk factors look like. Weibull is kind of fun to deal with. It gets used in certain cases, but Weibull is also a case where we look at different data, different ways to make sure that we're making sense. And exponential is how we measure those things that are occurring at random intervals that we don't have any foresight on. User requests coming in, messaging services, RabbitMQ, those things. We don't know when they're going to arrive, but we can measure when they have arrived. Similar thing, complex math, but again, on our library, the mass library does this for you. And we're going to grab these pieces. And so, yeah, using the same example, within 5 seconds, I've had 120 user requests come in, down to 10 at 20 seconds. I build that structure, that rate estimate, by simply making the call to give it that data. And then I get a rate number. And then I can say, what is the probability, what's the percentage that within a certain amount of time, I am going to see a call come in, a user request come in. In this case, I said, what is the probability that within 10 seconds a request is going to come in? And it turns out it's about 40%. And so this can give you the ability to look at things that are not directly related, but inferential to the overall environment. Which does give us this next thing, descriptive versus inferential. I've mentioned inferential twice. Inferential is when you don't have every single piece of data in place, and you're putting the data together, and you're making judgments based on the data that you actually have. Descriptive is when you have every piece of data, and you can simply calculate the final result. So when you're drawing the statistical conclusion, having all of the data is really, really useful, but we have a heck of a lot of data coming in. Had a customer at a previous company, when it was in this space, they did 48 terabytes of log files per hour. They can't actually analyze all the data that's coming in. And so they have to make choices about what their data looks like. Inferential uses that sample set, and they can use that sample set to figure out their conclusion. They can test against hypothesis, they can use it for visualization. The problem is that the minute we start touching inferential data, we're starting into sampling. And sampling has its own headaches. Monitoring is a data problem. We have more data coming in. The observability signals, which have shown up on the screen multiple times, metrics, traces, logs. Analysis is usually aggregated. It's analyzed in segments. What do we do? What data do we pick? And generally speaking, there are these methods of dealing with sampled data. And they can be purely random down to what's called purpose-led, purpose. I used to be able to pronounce that word, sampling. The samples that are coming in color your statistical conclusions. So, head-based sampling in the tracing world versus tail-based sampling in the tracing world. Head-based sampling, purely random. When a trace starts, I've decided I'm going to keep that trace. I have no idea what its conclusion is going to be. Tail-based sampling, when the trace ends, I'm going to look and see what the result of the trace was and make a purpose-led decision on whether I'm keeping it or not. Was there an error? Did it cross some boundary of time? The problem is that when you're looking at sampling, in either case, head-based sampling will miss whatever your percentage things are. You're sampling 10 out of 100, and it means 90 of them, you have no idea what happened. Tail-based sampling, you've got this wonderful thing, you know everything that went, quote, wrong, but in observability, part of the message is the unknown unknowns. When something happens that we don't know could happen, how do you find it on a tail-based model? And so we have these purely random to not purely random, where we go from retention rate as coverage to fault rate as coverage. And so sampling leads you to different conclusions. If you just grabbed numbers from a tail-based sample, you may find that things look really bleak. If you look at head-based sampling, you may find things look really good. Similarly, in this case, I'm looking at a head-based sampling based on the data, and it came down and said my latent distribution is 1 to 2 seconds. All gloriously good. 3.7 seconds or less, I'm happy with. When I look at all the actual data, I have at least one that's 29 to 40 seconds. I have an unhappy customer. Hopefully he regenerated his request. 3.7 seconds is likely to cause somebody to leave your site. So that data structure becomes a really unique case. Now the good news is metrics are not usually sampled. That's not always true when you're looking at metrics generated from tracing. And so red metrics usually and should never be sampled, but it quite commonly are. And it doesn't give you the ability to do that forensic link back because the data that you derived from may no longer be there. It is a necessary evil, but understand what you're getting into when you look at statistics generated from sampled data. So, quick summary for this. Statistics are how we measure or analyze our metrics. And there's a statement, incorrect, that I always like to point out. It says, on scale, probability is not your friend. Wrong. Statistics is not your friend. Probability is one event at that moment. It has nothing to do with scale. Statistics is all about scale for that. And the statistics tend to be aggregation and reduction to show those central tendencies. That's where we do. That's why they don't show individual behavior for this. Most of us make choices of very few basics. And by the way, that's a great approach to doing this, as long as you understand why you're choosing to use those specific basics. And finally, my favorite line, my favorite quote of all time. Brian Kernighan, 1979, Unix for Beginners. The most effective debugging tool is still careful thought, coupled with judiciously placed print statements. Statistics allows us to make those print statements meaningful. And with that, I'll turn this back over. My slides are on GitHub. I'm sure they'll be distributed. You can find me on LinkedIn. You can find me on the Nginx community site. And with that, I'll turn it back over. And thanks.
Awesome, thank you.
By the way, one last thing. That's the Dedekind 9th number.
Awesome. Any questions for Dave from the audience? Do a quick scan here. Make sure.
Stunned silence is the usual response to this talk.
Exactly. Well, what's funny is, as I mentioned before, I've been doing this series of like people pronouncing words, and I actually tossed in Nginx, which is how I pronounce it, and I was actually curious if anyone would pronounce it differently, and surprisingly, it was like out of 31, there was like one person who pronounced it differently. But
you do know that the first N is silent.
The which one?
The first one.
The first N?
Yes, and that's name is Jinx. You probably can't see it, but this is Jinx.
So wait, how do you pronounce Nginx?
Nginx.
Oh, God. Bam. Got me. All right, let's do a big round of applause for Dave. Thank you so much. Yeah, I should have had you on my show. All righty, we made it, everyone. You should give yourselves a big round of applause. Three days of really amazing talks. Thanks to everyone who was able to stick it out, and it's lovely having you all here. So I'm gonna just let Jason spend the next 10 minutes. Shut up. So you gotta drag the thing over.
Oh, I gotta find this one. Is that it?
Yeah, exactly.
All right, take it out of full screen.
So unfortunately, like I said, Alex was not able to join us for the final talk. So Jason's gonna do a short reflection. And it's a monitoring conference. It would not be a monitoring conference if we didn't have some sort of measurement. Click the drop down.
Got it. Shut up.
Google Sheets. Of course we're going to end with Google Sheets. Maybe nightmares about Google Sheets.
All right. Yeah, TIL Google Sheets. All right, are we good? Oh wait, no, we got to do.
Are we
full screen?
Yeah, make that full screen.
Full screen on that. All right. Okay. Actually, I had notes, but I don't remember what they were. Not these notes, like other notes. Closing notes. I guess we'll just do this first, right?
Yeah.
Okay. We don't need a break, right? We're good. Okay.
Do
all
it
right.
live.
Cool.
Do
all
it
right.
live.
Okay. I guess, show of hands, who's been here for one of my closing, metrics end of conference talks? Okay. again, I apologize. Pete implored me to do it again. I don't think we've done this since 2017. We kind of did some other things in between. But anyways, we're bringing it back. Oh, please don't send me. My wife is now telegramming me again. Okay, fortunately it's on this screen. I think we're okay. Okay. Y'all know how this goes? Number of Monitorama events served over the years. Number of Monitorama events hosted in Portland, Oregon. Number of attendees at last year's post-pandemic event. Number of attendees roughly this year. Number of CFP submissions this year. Number of CFP submissions accepted this year. Number of recruited talks. It just happened to be the Mastodon talk by Hazel. Number of backup speakers confirmed this year. Number of backup speakers pulled into action this year. Thank you both, by the way. Really appreciate it. Number of Slack members the last time I gave this talk. Number of Slack members today. Number of Blue Star donuts delivered. Number of Blue Star donuts consumed by yours truly. Actually, that's out of date.
Yeah.
2.25.
I was gonna say, sorry. I'm like, this is an inaccurate number. It's fixed now. It's fixed.
Number of coffee pour-overs served this week. Number of maximum strength cold and fluid gel caps consumed by me this week. I actually think I just have a sinus infection, but yeah. Number of peak concurrent live stream viewers this week. Total number of live stream watch time hours over the first 2 days. I actually don't know what the final total is. Do you know, Paul? No? Okay, we'll figure it out later. Number of days lost to underground fires this year. Number of days lost to ectoplasm leaks next door. Number of years we've held this conference. Number of times I've asked Pete if we should do it one more year. And number of years we're committed to keeping this thing going. That's it. Thank you very much.
It really is quite funny because a lot of people will come up to me and say, God, I heard a rumor that this is going to be the last Monitorama, and what's going to happen to it? And I'm like, I've been hearing that for a decade now. That is the last Monitorama, so don't get your hopes up. He'll do it again.
All right. Let's see. I have some notes somewhere. I have to find them. I'm not screen sharing, Natalie. Just FYI. Nat. Y'all are conspiring this year. I don't know what's going on. All right. Let's see, closing notes. Oh, just a reminder. Well, I guess first of all, again, thank you very much. Honestly, this has been a really fun week. Again, the energy was fantastic. I mean, I don't know if it's just, for the most part, not having to worry as much about masks and COVID. I mean, obviously that's still a danger and a concern out there, but like, I don't know. It was just a lot of fun this week. The energy was fantastic. The vibes were great. Just thank you, everyone. We will be sending out an attendee survey. I usually like to get those within the next week or so everything is still fresh on your mind. But I do have to travel back, so if you could just be patient with me, we will get those out, and I do encourage your feedback. Some quick thank yous again to all of y'all, to everyone for again a great week, positive vibes, some awesome discussions, lots of hot takes. It was a lot of fun. To our speakers for putting all the time and effort it takes to entertain us, to put their talks together, and for helping us bring this community together. So, round of applause for all of our speakers this week. To our sponsors, I mean, we really couldn't do this without their help. Thank you for our sponsors for coming out, showing us what's going on, giving us some fun talks on stage, and some creative swag this year. So that was a lot of fun. To Nosa Familia for their coffee and merch. Although my kids were doing the pour-overs, we were getting the coffee courtesy of Nosa. I mean, well, the ground coffee was on them. The iced coffee was on me. But that was really cool. And if you didn't get it, like there was a bunch of those free cards. Like they're literally gonna send you a free bag of coffee if you use that. So like, I don't actually know if they charge shipping, but I mean, I would still at least try it. But that's just me. To Searle Video for videography and photography. Paul and his team does great work.
When will those videos go to the Vimeo?
Yeah, Paul, when will those? Okay, so I mean, everything that we've captured on the live stream is up. It's going to be on Paul's channel. If you go to the watch link on YouTube, you'll be linked to his channel on YouTube, and you can see, I think, all of our events going back to 2016 that he's captured. So they're there. We will usually get them post-processed and uploaded to Vimeo within the next, I would say, 3 weeks, 2 to 3 weeks. Yeah. So did that answer your question?
It was kind of for the audience.
Okay, I couldn't remember. All right, cool. All right. To the Portland Center Stage, I honestly, this is why we keep coming back to this venue, because of Portland Center Stage and their amazing staff.
Amazing. There's a lot of people that are running around. You don't see. They're in the back. They're making sure everything flows well, and they just incredible job every single year. Every single year. Thank you so much.
Yeah. And I guess to our volunteers, I mean, this guy. No, I'm just kidding. No, honestly, I mean, Pete doing what he does allows me to just hide in the shadows and try to put out fires as best I can. Pete, thank you so much for everything you bring to the event. I mean, personality, I mean, you're all right, but man, you do a good job getting people on stage. So, yeah.
We're just an old married couple at this point, man.
Brad, Jordan, Wes, for doing a little bit of everything. I mean, we have volunteers that help us with this. They're awesome. I mean, last but not least, obviously my family. My wife, I was so glad that she was feeling better this year. Last year she had a back condition and she really wasn't able to help us out as much. But, you know, my wife and my kids just, you know, pitching in and making this a family thing was a lot of fun. What's that? Coffee? What?
Photographer.
What?
Photographer.
What about that phone? Oh. What did I, wait, huh? Thank you. Thank you. I said Searle Video and the team. I'm sorry, I did.
But that's not a video, so I think it threw people off.
I said video and photography.
Yeah. Okay.
I'm sorry, is it Kayla? Kayla, I am so sorry. I'm really looking forward to it, but thank you so much. Okay. It's time for a raffle. All right, let me grab the stuff.
I got the stuff.
Oh, you got the stuff? Okay. Are Brad or Wes around? It would be awesome to have runners. Awesome, thank you. I'll tell you. No. Okay, so that's a good question. All right, so I think I'm gonna start with these. All right, so our first two. Who's had Kova coffee? Okay, so don't let instant coffee scare you off. Like Kova is one of my favorite roasters, and they do an amazing job with their instant coffee. So like honestly, this stuff is fantastic for like travel as well as it is at home. So I love this stuff. And I actually had to run around to 3 different Kovas on Saturday to try to find enough. Well, I was getting more than these 2, but trust me, the math adds up.
Last, what, 4? Last 4 numbers?
Yeah, sure. I mean, if we happen to have 2 people at the last same 4 numbers, okay, we'll figure it out. Okay, last 3 numbers. Last 3 numbers? Last 4 numbers?
Let's do last 3 and see if we get a...
Yeah, all right, last 3 numbers. 477.
So when you got it, just like yell very loudly and we'll stop.
Yeah. 618. Oh, wow, this one's got more. Okay, I'm going to do 4 numbers from now on.
So
4 numbers. 8166. Yes, I heard somebody? Okay, do you drink coffee? Okay, awesome.
Up at top?
Balcony. We could probably throw it up there.
Oh, God, Brad's going.
No, I'm serious. It's... Okay. 7592. Okay. 8161. What? Yes. All right. Yes. Straight in the back under the, the light.
Go to the light.
Okay. All right, now we're going to do this. Okay, so we've got 4 of these. I guess if you're allergic to salt, just let me know. I don't know if it's actually, I guess if you're allergic to garlic, let us know. So these are Jacobsen sea salt, black garlic infused salt. It is literally my favorite seasoning. It's amazing. So we got 4 of those. 5739.
Oh,
So,
got it? All right.
okay, can you actually call out your entire number?
Do you think that's a confliction?
I'm curious. All right, that's fine. Okay, sorry, did you get, okay.
Yeah, we got it.
7607.
We got it.
All right. You good? Okay. Thanks, Wes. 8200.
We heard it. Oh,
Did you hear something? All right, raise your hand. Keep it up. Thank you.
Last one. Last all.
All right, last salt. 5668. Wait, you just won that. Oh, you had your hand up still. Okay, 5668. Wait, where? Who? Okay. No.
Check the ticket.
Wait.
No, check the ticket. I want to
You're already salty enough. All right.
T.
Okay. This is Smith Tea Maker. They make amazing teas. This is actually a 30 count sampler.
3 different kinds.
Yeah. Yes. It's their, how do you pronounce Genmaicha? Thank you. What they say. Pearl and breakfast and peppermint lilies. Yeah, it's actually really good. Okay, we have 3 of those. 8249. Okay. 8109. 8140.
We got it.
Keep your hands up. Keep your hands up. Thank you.
Don't think you got it.
8169. Okay. 7902. Who? What? Where? Wait. Did we already call you? Yeah, but you can't have 2 tickets. No. No. No.
Oh, amazing.
All right, throw the coffee back down. I'm kidding. But yeah, you're not getting any more. 8107. Who? Where? Where's your? Okay, awesome. Thank you.
One more.
All right. Pete. 7984. Keep your hand up. Thank you.
All right, and Garth.
Oh, okay. 2. Well, okay, 1 each. But 2 total Powell's gift cards for $100 each. Now, the great thing about these, besides being worth $100 each, is that you can use them either in person or online. So, yeah. But, I mean, you're right here. 7674. Okay, he's earned both. Just kidding.
No.
Raise your hand. 7674. Check the ticket, please. Sorry, we're getting into that territory. We have to trust but validate. We're good? Okay, thank you.
Wow, you held the raffle.
2258. All right. 7888. $5244.
Chance to get better each poll.
I know. 7758. Okay.
I know, I just want to win it so I can just put it in my pocket.
4945.
Oh,
All right. Yeah, that's it, right? That we don't have anything else? No?
Am I like?
Yeah, we're done. Okay, so you know, I'm kind of cliche, right? I like to be topical in my stuff.
The same way he's like a small child.
All right. Okay. First I tried to get it, well, I tried normal means. It wasn't the guy in the van with the donuts, right? No, okay. No, I tried Target, like, because every Target, like, in a 50-mile radius claims to have, like, 2 or 3 of these in stock, and literally none of them do. And then I got an email from one of them after I thought all of my orders had been canceled this morning saying that one that was, like, 10 miles away actually had it. Fortunately, I had already ordered one from Amazon yesterday, overnight, came into Whole Foods today, but it was in Amazon frustration-free packaging. So I didn't know if we were getting a nondescript cardboard box with a bunch of Legos inside or legit.
Just like a bag of Legos.
Yeah, just a bag of Legos, yeah. All right, enough. Oh, wait, I dropped one. I'll start over again. All right. And we are going to be validating this one. 7879.
Chances are improving.
I mean, I would at least try. I mean, 8172.
We got it.
All right, now, we got to check the ticket. This is going to be painful. Just throw it down. I'm sure nobody would grab it. You're totally fine.
Diving over each other.
Wait. Is Wes really going upstairs to like that?
Validate it.
All right. I want to.
can't even read that.
I want to say, have a great time. Thank you for being here, but we actually have to wait for this now. Oh, poor Wes. Where are you going? You could be missing out. You don't know.
It's like when the team is up by 6.
It's like the David Letterman show. Like, so all right, we have a winner. All right. Thank you all very much. I hope you had a fun week. I know I did. I hope we get to see you again next year. Have a safe trip home. Thanks, everyone.